Okay, hello everyone. Welcome to week 5. In this week 5, we're going to be focusing a lot on functions, system functions. We've seen a group of functions which are the aggregate functions. So functions are divided into different categories. Today we're going to be looking at date and time functions. But previously we've talked about aggregate functions. We did aggregate functions together with the group by. Right? Those are also functions belonging to the aggregate category. Uh, Today we're going to look at data time functions, and then tomorrow we're going to get to numeric functions. We're also going to look at string functions. Next week also we're going to be looking at functions. Right, this is just to make you understand that this is a very broad topic. Right, so this week and next week we're going to be looking at functions. So by the end of this week we should be able to have covered these functions listed right here. Functions are going to make your task as an analyst very easy. Right, a lot of things that we're doing previously we're using like the crude method, but with functions you can you can enhance your analytics, you can make it, you can fine tune it, you can make it much more better, and you can solve a vast number of questions just by knowing these functions we're going to cover today. Right, so the first thing I want us to talk about is system functions. I have this document right here. It has this one right here, SQL week 5 6. I will start off by skipping these two topics at the top. I will come back to them later on. We have I'll come back to views and I'll come back to subqueries. Let's just go to system functions. You can just scroll down, skip those two topics, views and subqueries. Let's go to system functions right here. Some people also call them built-in functions. Right, these are called built-in in the sense that they come with the application. I'll show you where they reside. Right, so Microsoft builds this function and embeds them within the application, and you can use them in problem solving. Right, so they're going to perform calculations on your data, just like what we saw on the aggregate functions. You can use them to perform uh, averaging, summation, counting, investigate the mean, max. Right, so we're going to see more of such functions today. Right, so how can you access system functions within SSMS? This is SQL Server Management Studio, where our system functions stored. And this is a clue right here. So every database has this folder, programmability. You're not going to forget this. Open any database of your choice on Object Explorer. Let's go to Academia, expand. You will see this folder right here, programmability. That's where it all begins. And if you expand on that folder, you're going to see functions right here. Expand on functions, you're going to see system functions right here. And this is the topic of today. Expand on system functions. You see the groups, and at the very top of the list you see aggregate functions. You're familiar with this one. And if you expand, you're going to see other functions we did not cover. So what we covered were the business oriented ones: average, count, max, mean, sum. These ones right here, they have statistical, like if you're doing statistics, the variance of the population, standard deviation, stuff like that. These are statistics and client functions. They use them more often in research. But the ones that you're going to be using daily in businesses, in your job as a data analyst, those 5 ones we did. Average, you must know the average function. You must know count, max, mean, sum. These are very important aggregate functions. You see that? So now this gives you an idea about system functions and how they are grouped into different categories. We've talked about aggregate functions. And guess what? Today we're going to be looking at date and time functions right here. And if you expand on that folder, you see the full list. We're not going to cover all of this. I'm going to focus on the key ones that you have to know. See that? So I just want you to see where these functions belong. They are called built-in functions or system functions for a reason. They are built by Microsoft. They come with the application. These are system functions or built-in functions, and you should be able to know where to locate them. So the good news is that every database has this folder. Every single database. Right. So if I go back and just click on some different database, this one created last week, go to programmability right here, expand. functions expand, system functions expand, and these are the different categories of system functions, right? We're not going to study every single one of them. We're going to study the ones that you need to know as a data analyst, the ones that have industrial application, right? We've already talked about aggregate functions, so we're not going to cover it. We're going to move to date and time functions. Any questions so far? So please remember where to find those functions. You'll find them in the programmability folder, which is available on every database. From there, you just go to functions, system functions, and you're going to see the different categories. So remember the name, programmability. Every database has that folder. If I go to presentation database, programmability right here, expand, functions expand, and you can see system functions expand, and these are the different categories of the system functions. Okay, any questions so far? The next thing I want to highlight is the fact that if you just put your cursor on any of these functions, see right here, returns the average of the value in a group. This is the average function. And you can also expand on it. You see, it takes a parameter. You see, what are the parameters? Expand. Every function, basically not every function, but the foundation of a function is that it's going to take in something, process it, and return something. So this is the expression you pass into the function, and this is what the function returns. So if you're processing the average, you have to specify a column to it. That's the expression you pass into the function. The function will process that expression and returns something. Average salary, it will get you the average salary. So returns integer. They give you the data type and stuff like that. So this is something you should remember. You pass in an expression into a function, and then the function will process it and return something. Right. And that's common to every function you're going to see. If I go to the date and time function, this one, expand, we're going to start today by looking at the function which will get the date and time. Each time you run it, this get date. It's a very simple function. Right. You still have that parameter structure, what to pass into the function. You're going to see this, and you don't supply anything to this function. It's going to return what the current date and time. See that? So this is the first function we're going to start. So if you see date and time functions, these are functions that act on date. The name tells you what the function is doing or what the function is going to act on. All right, so I cannot be giving salary into any of this function or first name or last name into any of this function. It must be a date. All right, that's why they call them date and time functions. All right, so let's get started. It's going to be an interesting session today. Please just pause me and ask questions. All right, functions sometimes they get tricky. All right, so just make sure you're able to draw my attention if I specify something that is not understood. Okay, let's begin this session by looking at this right here. I'm going to open this back to Management Studio. Just click on open, and next I'm just going to go to week 5, day 1, and this is a material we're going to start with. Week 5, date and time functions, open. This is it. All right. So, like I said, from the name, you know where these functions are going to act. Date and time functions, they're going to act on date. Right. And this is a link to W3 Schools. Let me share this link as well. I'm just going to put it on the chat window. I will also be consulting that website. All right. So the very first function on our list is a function that returns today's date, the current date and time. All right. This depends on your location, of course. All right. So returns the current date and time. And this is it right here. If I just put select, get date, and I execute, see, I get today's date and time, especially the time at which that function was executed. Right. And I want you to be able to understand this. If I copy that value, that's what I just do, put it right here. You see, this is a year. You have to be able to interpret what the system is giving you in return. So like we said, this function does not take any parameter. You see, nothing is passed into the function. We are simply asking the system to give us today's date and time at the time of execution. You see, so this right here, that's the year. This right here, that's the month. This is the day. This is the hour, minute, seconds, and the milliseconds. And just to remind you that this function will never give the same result. Right. So even if I execute this very close range, a couple of seconds will go by before the next execution. No matter how fast I try to run it, it will never give the same value. Right. And if you what you see right here is just start practice. Let me delete this and do it again so that you can understand. So I'm running this function, and each run I copy the value and I document it. Right. This is just to prove to you that this function will always generate a different value. Right. Because it is tracking down every aspect all the way to the seconds, milliseconds as well. Right. So this function is executed on the same day, so the date will be the same. You see, all this part will be the same. But then as you start moving towards the time stamp, it becomes different. Right, because a couple of seconds has gone by before the next is executed. So this is some very important thing to see. I want to document this so that you understand. And this behavior is what we could refer to as non-deterministic. So when you execute a function and each time it runs, it generates a different value, that function is referred to as a non-deterministic function. You cannot determine the outcome, non-deterministic. So it's not going to be the same for each run, right? And that's what I just did right here. I've documented the different values from each run. And you can clearly see that, yeah, this part is the same. You understand that this part right here is going to be the same because it's today. Right? All of this was run today. So that's the date. Now, as far as the time component is concerned, you're going to see differences on this side. See, especially on the seconds aspect. You see, this is seconds. Of course, a couple of seconds went by before this ran. This. You see, and even on the minute side as well, you see some changes. Right. So this behavior is what we refer to as non-deterministic. So gives a different outcome each time the function is called or executed. I want to stop right here. So this is the very first function we've seen. Right, this is a non-table based. You just simply type select and you just call the function, give me the current date and time. Nothing is passed into this function. If I execute, I get the date and time. So if you're performing an analytics and they want you to project the current date and time for that analysis, you know how to fetch that. You can just run this information and the system will put it right there. This is going to become very useful when you're building reports and you want to project the timestamp on the report. So that when the report shows, it shows the date and time right there. Right. So this is an automatic process to do that. You don't need to hard code the value. Each day you have to come and change the value because the date keeps changing, But if you allow the system to take care of that, just code it, the system will run and pull up the current date, you see. Right. So this is very important. So that's the very first function we have seen. And if I take you to the Object Explorer window, I just go to any database, the keys to get to the programmability folder. I go to functions, system functions. We are looking at what date and time category. I go to the date and time category. This is the first function we've just seen, get date. Right. And if you want to explore this function, you can expand and go to the parameters, see what the system needs. It says none. You see, this arrow is going into the function. That's what we call the input parameter. And then this one is going outside. That's what we call the output. So for the input in this function, nothing is specified, none. So we are providing this function with nothing. But what will the function return? You see, the return is what date and time, and that's what we get when I execute this. right? So you have to understand the parameter side of a function. What does this function need? What do I need to provide? And then what will this function return when I execute? So this is a very special kind of function. It takes nothing. The input parameter is none. What does it return? It will give today's date and time as configured by your location or your laptop. Those are in a different time zone will get something different. You see that? All right, so this is one very important function that we discovered. Another aspect of this function, it is non-deterministic, and you have to know what the meaning of non-deterministic is. So this function gives a different value each time it is executed. Okay, any questions so far? Okay, I'm gonna skip this one. Some other people use this. This is also a function that will give you current time, date and time. But this one does not take a parenthesis. This is something you have to watch out. If I do this and execute, I get an error. Right. But it's sufficient for you to know this. Right. I'm going to show you this on the list. This is also on the list right here. See, it doesn't take any parenthesis. So these two functions, if I execute them, see, I'm getting the same. Right. So I don't want you to stress yourself in knowing this. The most important one to know is this one. So if you're asked to code a function that will return current date and time at execution, is just know this one, right? Now, once we're done with this, I will now take you to a very interesting part, the parts of a date. What function can you use to extract just this part, the year? What function can you use to extract just this part, the month? And what function can you use to extract just this part, the day? And all of these functions are available. We have a year function, see? So extracting the parts of a date, these are the different parts of a date. We have the year, we have the month, we have the day, and then on the timestamp we have hour, minutes. I'm not going to bore you with this extraction. You're not going to really do this in businesses. Businesses will be interested in this part. Show me sales over time, and then time is in years, right? Show me sales across the different months. So you have to use a month function on a day to extract sales over day. See, so these parts are very important, right? So this function right here is what we will use to go extract just this part of a date. That's why we call this extracting the part of a date. In some analysis, you will need just the year. You don't need the full date. You need just the year. So how will it go in and extract just this? And that's where you use the year function. Returns the year part of a specified date. So when you use this function, what you pass inside must be a date, so that it will go into the date and just fetch the year only. All right, that's an interesting function. So let me show you where that is found. We are still under date and time function. What do we see right here? The year function. This is it. If I expand, I go to the parameters. What is the input? An expression which is a date. So any column you want to pass into this function, it must be a date. What will this function do? It will take that date, process it, and return to you what? Integer, which is the year. See that? This is very important. Let me just give you a date at random. I have this date. Select. I have 20, 24, 01, maybe 25, something like this. This is a date. If I execute, that's a date right there. I want you to extract just this part from this date. And when you study closely, you see that, hey, this is a year. Okay, I need the year function. So I'm just going to type this. I put year, and then I put the input environment, and I copy this. This is now going to be the expression I'll pass into that function. Right. So this is the year function. For the parameters, the input is an expression or a date. This is it right here. And it will process this and return what? Integer, a number. And based on this part here, it will simply extract this. So you have to understand why when I execute this, I get just the year part because I'm using the year function. It just goes and plug this. Right. Maybe I stay right here and talk about the others so that you see the full picture. If I'm interested in the month, I can use the month function. I call pass the date. I cannot execute this like this, you see. This function says the expression is needed, what you supply to the function. It's unlike the get date where nothing is passed in. See? So in this case, I'm interested in the month. So it will skip this. This is a month. It will return this part. So if I run this, I get the month as an integer. So we all know second is this is the month. Which month is second on the calendar? This is the month of February. I will show you another function that will give you the actual name. Right? And then if I'm interested in just the day, yes, I have the day function. Right? I'm just going to copy this and switch it to day. So I just want to stay right here and show you the three functions which you're going to use in extracting part of a date. And you have to understand what each is doing. The day function simply goes into a date like this and extracts just the day. By the way, I hope we all understand that in a date, this right here is the year, followed by the month, followed by the day. Right. So if you're putting the day function, goes into this date, extract just this part, the day. See that? And if I run this, you should be able to understand why we get 25. Because it is the year function, it is going into that expression and extracting. So we're extracting parts of a date. These are the three scenarios. Right? I really want to put them together so you understand. Then we're gonna do one after the other. Right? Are we okay with this? Maybe when we look at examples, this is gonna be much understood. Right? So remember, for all these other functions, you must pass in something. In the year function, you must be passing a date. So I cannot put, for example, a non-date expression. I cannot go put the city of Dallas right here. This value is not a date. So the year function cannot be supplied like this. You see, the expression, the input expression must be date time. You see, if I execute this, this is just provoking this function. You see, conversion failed when converting the date. You see, it wants to see a date. Right, you cannot go type in a number right there. It must be a date. Take note, the focus of today is what we call date and time functions. So all the functions we're going to see today are based on dates. Right, this is a string. We're going to see string functions later on. Right, I will touch base on string functions later on. Right, see, SQL string functions is different. Functions that act on numbers, we call them numeric functions. Functions that act on dates, we call them date functions. What we are studying today is date function. Year is not a string function. So don't use this function and pass it onto an expression that has nothing to do with the date. Right. So please remember, the goal of the year function is to visit a date and extract just the year part. Extract. It's an extraction functions. If I run this, you understand why this is projected as the return integer. Same thing with the month. The month on this date is February, but the system is not going to return February. It will return the number that's integer. 2 corresponds to February. On the day, this is the year, this is the month, this is the day. The day function goes into that date and extracts just this part. See, when I run this, this is what to get. So having explained these three scenarios, let's now go into examples so that we can see how we can use this. I'm going to skip this. So everything was explained on that side. This is it right here. So I have this date and time. This is it. I use the year function, go into this date, and return what? Just the year. So it's just going to return this part. So when I run this, this is what I get. See? Same thing right here. I just go fetch only the year. So I get 2018. Execute. Right. So you see that in these dates, they were static, hard-coded. Static. Or how do you make it dynamic? You see, I've nested two functions. You have to read this from the innermost part. Go fetch me the current date and time. That's the get date function. And then use the year function to extract just the year from this date. This is what we call nesting, and this is a dynamic process. In the next 10 years, this function will still be valid. Right? But this one is always going to be the same. It's always going to be 2018. Why? Because it's hard-coded. This will always be 2023. This will always be 2023, you see? So this is static or hard coding. If you want to make it dynamic, fetch the current date, that's the get date function, and then go extract just the year from that date. This is really important. All right, so we studied two functions that we are bringing them together as one. What was the first function? We studied how to fetch current date and time using the get date function. All right, so the system goes and executes this one, gets this value, right? And then it will now use this value and say, get me the year from that outcome. So the year from this outcome. This is hard coding because I've hard coded this value. In 30 years to come, this is always going to be 2024. It's hard coded. It's never going to change. You see? But then how do you make this process dynamic? All right. Call this function, and instead of hard coding this value, use a function to fetch that information. So I'm going to copy this function and put it right here. This is what we call dynamic coding. So the system will first of all execute the innermost function, which is what get did, and it's going to run this. It's going to give us this value, and then the year function will now attach itself to this result and just extract the year. Dynamic coding, execute. That's why we have this. Next year, this function will be valid. Why this will fail? 2 years from now, it's also going to be valid because it's going to keep fetching the current date and time and then extract the current year. That's how programmers have to code. If you're building a report in 2024 and you're doing this thing will remain always 2024. See? When the year changes, this will never change. And as you see how report developers, each time a year changes, they go and start hard coding, changing the values of changing the year on the dashboard they're building. But if you make it dynamic, as the year changes, this function updates itself and fetches the current value. This is never going to go outdated. You see? So you have to pay attention when you talk about hard coding and dynamic coding. The system runs itself and updates itself. There should be no manual work when you're going. You see, the year changes, you go to all your reports and change the year. Now, the system should do that for you. Dynamic process. Right. Let's do an example on a database. So let's connect to the employee database. And I'm going to give a question right here. So list of employees hired in the year 1991. Now, I want you to see this in real practice. If you know about the year function, this is going to be an easy question. If you just explore that table, let's run this. See what I did right here? I used the higher date year function on the higher date. This gives us what's the higher year. In fact, let me build this separate so that you see the build process. I'm gonna go right here. So this is the question right here. It's based on the employees database. Employee. Right, and then let me just investigate the table. Let me first of all run this and dbo dot try employee. Still a problem. Just a moment, let me go check the database. I should be missing maybe the schema. Employee database A, B, C, D, E right here. Go to tables. Yes, I was missing the schema. See, we have an employees table, but it is not in the DBO, it is rather in the HR schema. Now this is accurate. Oops. So this is a table right here. We have employee ID, name, job name, manager. The column we are focusing on is hire date. List all employees that were hired in the year 1991. See that? Now we need a where clause right here. You cannot just put hire date equal 1991. You cannot do this because hire date has three components. There are three parts to the hire date. We have the year, the month, and the day. So you cannot take a component that is capturing three sets of information and you equate it to something that has just one set. Right? So this is not what you will do. You see that? This is very important. Now, from your knowledge of the year function, you recall that yes, we can use the year function on the hire date so that the left hand side will be on the same structure like the right hand side. This is not balanced. This has three parts. We're equating it to something that has one part. So we can go to this side and bring the year function, right? The year function will go into the hire date and extract just the year. So this part is year, this part is year. This is very important. I want you to see this. Previously, it was not the same. We're comparing a date, three components to a single component. If you put this, we now go to the year and just extract only the year part. And if I copy this same stuff right here and put it right here so that you can see before executing, let me show you this. So I've created a last column called, this column has no name. And what is this column doing? It is simply going into the hire date and it is extracting the year. So on this row, the year was 1990. The extraction is right here, 1990. On this row, the year was what? 1991. This is the extraction right here. So this is how that year function is operating on that column. You see, now we can take this and compare it to this side. This is basically it right here. You see that? But you cannot do this comparison. See, you cannot do this. See, now you're getting an error. So the goal of this function is to make your job easy as an analyst. You see that? You're going to code much better when you know these functions, right? So what we need to do is just to make sure we're extracting just a year from the hire date so that it's now on the same path like this one. That's it. So if I run this, see what we get. See? We are simply showing only those that were hired in the year 1991. That's it right there. Any question? And there's a second option on this one where this is the primitive one where you just have to go check out the range for 1991. 1991 starts on this date and ends on this date. We are now treating it as a range. The year 1991 has a start date and has an end date. So that now we don't need to do anything on the hire date. Right? We can now say where hire date between this start date and the end date. This is somebody who doesn't know the year function. You see, it's a longer route. See? But then this is somebody who understands the year function. You see? makes this a clean solution right here. So before knowing the year function, this is what we'll be doing. See, you can now go back and improve those examples we solved in the past. See, but then you see, I want you to compare these two strategies. See, that the one involving the year function is just clean, straight to the point. That's what you get right there. But in interpreting 1991 as a range, you have to find the start date, the end date, and everything in between. Now that's too much work. See, so I really want you to appreciate this. This is a typical example of how the year function can be used in problem solving, and there are many more. You see, any question so far? And then there's this one comparison operator. We don't make use of the between. We use this greater than that, greater than or equal to, less than or equal to. So these are three strategies, but the best is this one right here. Right. Let me see if there's an example. List of employees hired in the year 1991 and 1992. These are two values. That's an in operator. Same thing. It becomes more interesting. Use the year on the higher date in 1991, 1992. See how interesting this is. And of course, we know that the in operator is a shorthand for multiple ors. You can expand it like this. Higher year equal 1991, or this equal this. See, but then this, see how interesting this. Without knowing the year function, it will take you a while to figure out the strategy to solve this question. But when you know your year function, that's just apply it, and that's it. Right there. This is really easy and straightforward. Yes, you can also use this strategy, but this is, in fact, the best is the first one. This one right here. We have 2 years. We are tracking employees that we hired in those. That's it. Just two values. This is what we do. See, right here. So these functions are going to help you a lot, right, to solve questions. If you look at this is how we find the number of employees in that table, and this is an aggregate function. See, 14 employees in that table, right? So 14 employees in that table, and that's the same thing we see when I do this HR dot employees. There are 14 employees in that table. See, 14 employees. So to count the number of employees, this is the process right here. Right. Now, if you're asked to look at the number of employees hired per year, of these 14 employees, how many were hired maybe in 2011? How many were hired in 1990? How many were hired in 1991? How many were hired in 1997? How many were hired in 1992? See? Now, this is going to be a breakdown analysis. See, I show the year right here, and I do the count. There's something very important I want you to see right here. Number of employees hired per year. Let me extract this and build it on a separate window so we can appreciate it better. Right. There's something interesting I want you to realize. So this is a table we're dealing with. We want to look at the number of employees hired per year. Right. There's something right here I want you to see. The year function is not an aggregate function. And what was the rule? The rule says that we should group by the non-aggregated column. So if I put year, I don't want to put higher date. This is not the question we're looking at. Higher date, and then I do a count of the number of employees. That's not what we're looking at right here. We're looking at the number of employees hired per year. So you have to do a transformation on this date to focus on just the year, not the full date. For the number of employees, we're going to be doing a count on the employee MID. This MID. This is the column right here. Right. So please take note, this is not what we're doing. We are number of employees hired per year. We have to go to the hire year and extract the year of hire. This is what we are expected to do for this question. Right. So I'm going to do this extraction right here. Now, this is the point I want to make. This column right here is a non-aggregated column. Hire date has not been aggregated. This is not an aggregate function. And that's the label I made right here. Because you might look at this, all right, this is a function that has been used on this column, yes, but it is not an aggregate function. So hence, this is a non-aggregated column. This column has been aggregated. Yes, this is an aggregate function. So we have an aggregated column. You have to group by the non-aggregated column. That's why we have this right here. This is very important. This is something I want. If I run this, you understand it's going to fail. We need to put this into a group by. This column is non-aggregated. We have to add it to a group by. Now, if I run this, out of the 14 employees, 1 was hired in 1990, 10 were hired in 1991, 1 was hired in 1992, 2 were hired in 1997. And if you sum up all of this, you get to 14. So this is the distribution of the employees over the higher years. This is very important. You see that? All right, so you have to understand this. This function has been used on this column. Yes, this function is not an aggregate function. You have to group by all the non-aggregated columns on the select list. Right, this column has been aggregated. This count function is an aggregate function. Year is not an aggregate function, it's a date time function. Hence, this becomes a non-aggregated column and it has to go into the group by. This is very important. Right? As we're studying more functions, don't lose track of what an aggregate function is. Right. So that's the examples on years. We're going to see more of this. Any question on the year function? Okay, let's take an example on the month function. See, returns the month part. This is an integer. It's not giving the name of the month, but just the month as a number. There are 12 months on the calendar, so it's going to give you any number 1 to 12. Right. So this right here, we're not interested in this part. This is where our focus is. So if I put the month function, it will simply go into this date, that expression, and return just this part. Right. That's what you see right there. See? This is very important. Same thing right here. It's just going to extract this part. This is what you get. See? So whenever you're doing an analysis and the focus is on the month, but there's no month column in the table, you can create it from a certain given date. See? And this is it. Right here, this is what you get. See that? Right. And again, this is nesting. You put one function inside another. The system begins by executing the inner one. So it fetches today's date and then give me the month corresponding to today's date. We're in the month of February, so we should get 2 right here. Right. So it fetches the current date and then use this month function to return just the month of the current date. You see that? Right. Okay, let's take an example. List of employees hired in the month of February of the year. This could be a tricky question if you have not studied these date functions. But it is going to be a simple question if you understand that, hey, for the month of February, we just have to put the month of the hire date equal to 2. And then the year 1991, we've solved this previously. Just put the year of the hire date equal 1991. This is what I'm talking about, this condition. You cannot in any way think of this scenario. In fact, let me show you. Let me explain this on the side. Right, you cannot remove this and just put higher date equal to this. We've addressed this. These are two different concepts. This is tracking down three sets of information. This one is just one. This you cannot compare the left hand side and the right hand side. They're not on the same structure. Same thing on this. You cannot put higher date equal to 2. Right? We 2 year represents the month of February, which is 2 on the calendar. See? So you should be looking at the month of the higher date equal to 2. And if you also misinterpret this and put February, the month function does not return a string. This is you misinterpreting the month function. The month function does not return a string. The month function returns an integer. If you go to the functions we've talked about, let's stay on this. Expand, go to the programmability, expand, go to functions, expand, system functions, expand. We are looking at date time functions. See what the documentation says about the month function. This is it right here. If I just put my cursor on it, returns an integer that represents the month part of a specified date. So this right here is a misinterpretation. This function returns an integer, a number, not a string. Right, and if you expand and go further to the parameters, it takes an expression. Yes, we've provided the expression. In this case, it's a date, the higher date. After taking that expression, what does it return? It returns an integer as a number. So you have to interpret that February from a numerical perspective is the month equal to 2. Right. This is very important. Also, if you just place your cursor, it gives you information. It's a built-in function. Month takes an expression, then returns integer. So it should make sure that you're capturing an integer on this side. And that's how you're going to solve this question. Mistake right here, you have to transform this into a year. 1991 is a year, that's not a date. So you have to make sure that you code it on this side. From the higher date, extract the year and make sure that the year is equal to 1991 as per this question. And that's how you're going to solve this. List of employees that were hired in the month of February of the year 1991. And if I execute this, just 2 employees. And if you look at the higher date, see, the 2 conditions are met. First, the year is 1991, the same. Second, the month is February. We don't care about the day, right? They didn't give us any condition on the day. It could be any day, but it must be in the year 1991, and the month must be the month of February. Questions? So you have to practice these things, right? You have to practice them, right? And then you see, if you sit back and try to solve this question without making use of these functions, it will be very tricky, right? But then the use of these functions, they make your solution very simple and straight to the point. And anybody looking at it will understand, okay, this is a year function. It goes into the higher date and extracts the year. I want to make sure that the year extracted should be what, 1991. Yes. Why are we using the AND operator right here? Why not the OR? Because these 2 conditions are mandatory. This must be true. This must be true. And the AND operator helps us on that. It makes sure that the expressions separated by AND are both mandatory. The year must be 1991. It's not negotiable. The month must be February. That's 2. And this is it right there. We've added 2 columns. This and these columns are simply built from this one. So this is a higher year, which is build from this using the year function. This is a higher month, which is simply built from this using the month function. And that's the two additional columns right here. If you know the year function, you know the month function, then you also know the day function, right? What does the day function does? It returns the day of the month of a specified date, right? This is the date I've provided, hard-coded. Let's go into this date and return the day. This is the year, this is the month, this is what we're interested in. 6. 6th day of the month of August of the year 2022, right there. See? And this one also right here. So we are skipping this part, and this is what we are returning. See that? Right. And if you want to make it dynamic, first you fetch the current date. Yes, this is it. And then you pass that information into a day function. The day function will return the date. And of course, day is also going to be 1 to 28, depending on leap year or 30, 31, stuff like that. So this extraction right here is today's day, 17th of February. All right, this is going to give you that 17th of February 2024. All right, and the timestamp right there. But if you put the day from that expression, it will simply go fetch 17, and that's why we get 17 when we execute this. All right. Are there examples on that? Yes, let's see some examples. So I've just added a new column right here, which is built from the hire date. Go to the hire date and just return the day the employee was hired. So I'm showing you the full date and simply the day. Right. Now let's further this. Employees hired on the first day of any month. What will be the interpretation? On the first day, this should be equal to 1. See how they can ask you a question and you just use your logic to arrive at the solution. Employees hired on the first day of the month. First day of the month, when you put the day function, it should be equal to 1. When you see 1, for example, yes, this employee was hired on the first day of the month. This is it. See? Which other example exists? I think that's just it. Just one employee was hired on the first day of the month. And so this is the logic you're going to code. Other people will do this differently, but this is the simplest logic you can easily understand. So yes, can you solve this kind of question? Yes. And that's a simple logic right there. We don't care about the month, we don't care about the year, but we care about the day. It should be the first day of any month or any year. And this is it. So you have to put the day of hire date equal to 1. And this is the extraction this person qualifies. See that? Yes. If you look at the hire date, it's the first of a certain month of a certain year. Right. We have this popular database we've been looking at, the Global Superstore. Show me a list of all orders that we place on the first day of any month or year. First day of the month. Yes. Now you can solve that question. Let's connect to the Global Superstore and let's use the orders table. Select star from, this is dbo dot orders. Yes, execute. Yes, give me the list of orders that we place on the first day of the month. List of orders placed on the first day of the month. So I'm getting the list of orders placed on the first day of any month and year. You know there's an order date, so you're going to be using this. This is the date the order was placed, but we're not interested in the full date. We want to see the first day of the month of any year, right? So this will be the condition you're going to put in place, where now you're going to use the day function, right? And make sure you apply that on the order date. order date. This is it right here. All right. For this to be the first day, this should be equal to 1. That's the logic. And then we execute this. We have 51,290 orders. Run this. We have 148,489 orders that we place on the first day of any month. We don't care about the month or the year. All right. And I can just go right here and say, hey, you know what? Can you order this? Order by. I can then drop this order date stuff. Right. I just want to show you the full list. Focus on the order that you see. Each of these orders we place on the first day of the given month and the year. If I want to focus this analysis only for a particular month, and let's focus this analysis, list of orders placed on the first day let's drill down this into a specific year. See that? So now I've added a year condition, right? And you're still going to be using the order date. See, so this is a condition on the day. I need to make a second mandatory condition and now point it to the year. So this is now going to be year order date. This should be what? Equal to 2014 as stated in the equation, right? So there will be a reduction in the number of orders that will qualify since I've added 2 mandatory conditions, right? So if I run this, right, something has added. You see, it has gone down to 442. Compare it to what we had right here. Without any condition, this is the total number of orders. We're looking at, this is the, you see, 51,290. How many of these orders were placed on the first day of any month and year? So this is what we get. Now let's narrow it down to a specific year, 2014, still the same first day. See, 442. And all of this, you see that the orders came in 2014. See that? Let's say December is a busy month for most businesses. I'm going to update this and zoom into the month of December. So list of orders placed on the first day of the month of December of the year 2024. See that? Series of conditions. So the month should be December, right? So first we start off with the day, first day, and this is the condition on the day of the month of December, and we need another condition right here in which you address that, right? So I can just copy this and transform this condition into what? Into month. And you have to remember that the month function returns a number. So you're not going to be typing December on this side. You're going to be typing 12, right? And this is mandatory condition. We continue that. See that? So this one is a little bit different. It has three conditions that must be met. First, the day should be the first day. Then second, the month of the other day should be 12, that's December. And the last one we are looking at, the year should be 2014. And if I execute this, this is what we get. See, we are down. You see, the more strict conditions we are adding, you see, it is affecting the number of rows returned. And if you zoom into this on the other date, you're going to notice that each and every one of these orders, first, they were placed in the year 2014. That's the first thing you realize. All of these are 2014 orders. Second thing you realize, they all came in the month of December. See, that's that month condition fully implemented. And the third thing you see is that the day of order was the first day of the month of December of the year 2014. And that's it. Just imagine how you're going to solve this question if you did not know this information, these functions right here. So functions are very critical. They are very strategic. They will help you as a data analyst to solve a vast number of questions easy and straight to the point. You see, all right, this is really, really important. Okay, I will share this video. I'm just going to copy this and add it to the chat window. Right. And the goal is for us to add that. Let's incorporate that in the lecture material just directly below this right here. Before we go into this end of month function, I know some of you already have that question. What if we're not looking at the first day of the month? What if we're looking at the last day of the month? Yes, you can also solve that using the end of month function. Yes, that's very important. So I want to find a spot and put this right here. So these are further examples to demonstrate that concept. So just like we said, what if you're not looking at the first day of the month? You are rather interested in the last day of the month. So there's this special function called E of month. This is simply N of month. So it's a month function, but then you put EO at the beginning to generate what we call an N of month function. Right. So if you specify any date and you just simply put N of month, please, this is a date. This is not an integer. This will give you a date. Right. It's going to give you the date that corresponds to the end of month of whatever value you specified. For example, we are looking at the 25th of January. So it's going to focus on this month, right, of this year, and it will project it to give you the last day on this. It's going to use it as a platform and then project it to give you the end of month corresponding to a typical date like this. So it's going to be a projection, right? And this, so it's a date. It is not like the month function which gives you a number, right? It is projecting the date. This is very, very important. The date within this framework, the last date on this framework. For example, if I get today's date right here, today's date is what? The 17th of January or February 2024. If I now put end of month, when does the current month ends? Is the date the current month ends? The current month ends on the 29th. You see? I don't know if you can see my calendar. Let me see if I can get. Now you cannot see my calendar. Yes, I'm just checking the calendar. Yes, this current month ends on Thursday the 29th. So that's what the end of month function is giving you. You have to provide it with a certain date and then it to do a projection based on that date and tell you the last date of that month. That's what they call the end of month function. It is not an integer like what the month function is doing. The month function is returning you a number, reporting the month of the date you're investigating. But the end of month function is reporting a date that corresponds to the last day of the given month you're investigating. See that this is very important. So if I now ask you, employees that were hired on the last day of the month, right? We've just seen how we can do employees hired on the first day of the month. We use the hire date function, we use the day function on the hire date, make it equal to 1. These are employees that were hired on the first day of the month. To get employees that were hired on the last day of the month, that's an end of month function, right? So I need to put that transition right here, indicate that we're using the employees database execute, right? So that we can follow through. So employees hired on the last day of the month, it is simply, since this is a date, you can just put hire date is equal to the date that is returned by the end of month function. Please take note that the end of month function returns a date. So you want to make sure that you quote the hire date should be equal to the end of month date returned by this. So when these two agree, then that employee was hired on the last day of the month. So if I execute this, I get an empty set. Yes. All right. And if I just run this without a condition, let's investigate it together. Let's visit each of these dates and see which one is the last day of the month. This is 28, but this is not a leap year. This is the first. See, so none of this is the last day of the month. See that? Let's transform this into using the global superstore. Let's go back to the global superstore. Let's look at orders that we place the last day of the month. Orders that we place on the last day of the month. I think we will definitely be lucky to see some good examples, right? Because we are dealing with a huge data set right here. So global superstore, let's look at orders that we place on the last day of the month. List of orders placed on the last day of the month. So list of orders placed on the last day of any month and year. Yeah, let's just keep the month and the year open. Right. I'm kind of repeating that analysis, but now using the last day of the month. Right. So yep, let's get to work. So on this one, this is what we have. I'm just going to put this right here. Run this. All right. So we know that for the end of month, there is an end of month function. Right. So all you're interested to do is investigate whenever the hire date is equal to the date returned by the end of month function. So we're dealing with two dates. Right. So I'm putting where hire date. It should be easy. No, not hire date. Sorry, order date. I'm sorry about that. This should be order date. So whenever the order date is equal to the date returned by the end of month function, please take note the end of month function returns a date. That's why we're not manipulating this. This is a date already. Right, but then we are now investigating whenever the order date is equal to the date returned by the end of month function, then that's an order that was placed on the last day of the month. See, this is an investigation right here. Yes, pretty much we have a good deal of orders that came in on the last day of the month. We are not interested in the given month, neither are we interested in the specific year. The question did not mention that. Any month and year. And if you look at what we have right here, let me just go ahead and order by the order date so that we have some sorting on the final result return. Let's order by this. All right, let me just run this part. Now, if you take a close inspection on each of these dates, this order came in on this date. This is 31st January 31st, 2021, 2011. Yes, this is the last day of that. See, last day of the month. All those 30. See, this is 28. Yes, this is also valid. You see, so you see, strictly only orders that came in on the last day of the month. See that? Right. And let's do the same thing we did. Let's add a condition on the year. So I will just copy this, and similar to what we did previously, I'm going to do in the year of our list of orders placed on the last day of any month, the year 2014. Right. So this one has a condition on the year. And how do we do that? We just have to add that condition right here and make it mandatory. So in this case, the year of what? The order date should be equal to 2014. And this is the order date column. I'm just going to copy that and put it right here. So this is the condition that will take care of the year and make sure it is equal to what? 2014. Right. This is what is taking care of the end of month. The order date should be the same as the end of month. This is an order that was placed on the last day of the month. This guarantees that the order came in the year 2014, and it's a mandatory condition. So if I run this, see what we have. Right. So the first thing you see, all of these orders were placed in the year 2014. We have 593 of them. First condition, you see. Right. And then second condition, all of these orders came in on the last day, see, 31st, last day of that given year. Right. So February 28, 2014, that's the last day. If you check the calendar for 2014, this is going to be the last day on that month and year. See that? Yes, and we can do the same. Let me just copy this condition again and extend it now by adding a month filter. Last time we did for December. So of the month of December, I'm just going to add that condition. So list of orders placed on the last day of the month of December in the year 2014. So there is a condition on the date, it should be last day. There's a condition on the month, it should be December, and there's also a condition on the year. Right? Yes, and when it comes to adding these conditions, you can put them in any order. So you're just going to focus on what we have. We have this, which is the last day of the month. We have this, which is a year. Let me just step in right here and add one, which will focus on the month. Right, so for the month, I'm going to use this and just specify that the month of this given date, order date, should be equal to, this is the point where you remember month returns an integer. Just put your cursor on it. And so you should be putting 12 right here, not December. If you type December right here, that's a string. The month function does not return a string, so you cannot equate it like this. This is very important. These two are not of the same data type. See that? This extraction right here returns an integer, and you're equating it to a string. That's not correct. So this should be equated to 12. 12 corresponds to December. See that on the calendar? You see. Now, this takes into consideration all of those conditions. Last day of the month, this is step end of month function, investigating to make sure that the order date is the corresponds to the last date on the month. See, this is a condition for the month, making sure that it's December, the order came in the month of December. And then this is another condition for the year, making sure that we are looking at the orders that came in 2014. And this is it right here. And we can investigate all of those conditions. First, we are still dealing with 2014 orders. You can see right there, all of them are 2014. Right. Second, these are all December orders. You see, the month there is December. And then finally, you can see that these are all December 31st. Yes, the last date of this is that, you see. Yes, and this is how you can do that. Right. So I'm going to share this. So we have three scenarios: end of month, considering the month and the year. I think I did a mix up right here. So this is the first one, just the end of month, correct? This one has to do with the month of December in that. So this was supposed to come before this one. So in this one, we just brought in the year first. So we have this. And the last one, we have a 3. Yes, this is the order in which we should specify them. Okay, I'm going to share this. You can just add it to the lecture material and save it. We're going to add it to the order end of month segment on this segment right here. So this is the example for end of month. And I'm just going to put it right here. So if you can do first day of the month, you can do last day of the month, and then you can do any day, and that's where this is taken care of, any day. For example, employees hired on the 3rd day of any given month. You see, it's easy. Just put the day, make it equal to 3. If it's the first day of the month, you put 1. There's no negotiation on this. First day is first day. Right. The issue is tricky when you're talking about the last day of the month. Some months have 30 days, some months have 31, others have 28. So there's that confusion, you see. Another way, instead of using the end of month function, you can actually use the day and you put it like in a list environment with all the possibilities. Yeah, but that's still going to be confusing, right? So the best is to use this. All right, so first day of the month is easy. The day on the higher date should be equal to 1. Right. Last day of the month is tricky because different months have different last dates. See? So that's why the system built a special function called end of month. You can explore that. And then any other given date, you can just plug it in. List of employees hired on the 3rd day of any given month. This is it. This is the day function. Extract equal to 3. List of employees hired on the 14th day of the month. You just put day hired equal 14. So now you understand how to plug any scenario. First day, any date, or end of month, all those you know how to navigate your way around those requirements, right? So we've done 3 of those key functions. I think let me pause right here. I'll take you to that not W3 schools. I'll take you to the other one. This website right here. I'm just going to share this link with everyone. Right. I'm going to paste it right here. Now, the concept of date functions in this documentation is treated under intermediate SQL. So at the top you have basic SQL, intermediate SQL, and the very last topic on intermediate SQL is what we're studying today, date function, this one right here. The name date function simply means these are functions that will act on dates. And in all these examples we've been working on today, you see we are passing dates. The columns we are exposing to those functions are dates. Right. I think the extraction, this tutorial is going to be useless because the extraction is different. This is PostgreSQL. Right. This is completely different. Right. So please, you're going to skip this. Right. You see these extractions right here. That's not how we do it in SQL. In SQL Server. For example, in this tutorial, you use this data set Microsoft, which contains messages on Microsoft Teams. I think we have this database. Yes, this website, this particular topic is going to be useless if you use this tutorial. It's going to be a complete waste of your time because the extraction process is different. This is not how we extract day from a date. We just use a day function. Right. So yes, if you use this approach, it will be a waste of time. Right. Please don't read that concept from that website. So let me see, do we have Facebook? Yes. For example, let me give you a practical concept right here. This is a practice problem. I'm going to click on try out, and this is it right here. So you're dealing with the Facebook database. So giving a table of Facebook posts for each user who posted at least twice in 2011. Now we have a database Facebook. For those who attended the review, which I know everyone did, you can just do use Facebook. There's a database called Facebook. And on the Facebook database, we have a table called post. So select style from DBO dot. I'm missing something right here. Post right here and execute. It's the same information you see on this side. If I just click run code, you're going to see the post. So the user ID, the post ID, and the post content. So these are posts on Facebook. This is a user who made the post. Each post carries a post ID and then the post content. See that this is what Facebook is tracking from their own side, right? So each post has a user ID, the post ID, and the content, what was actually posted, right? So we're dealing with this. These are the records right there. It's the same information you see right here. Now let's go back to the question. Given a table of Facebook posts for each user who posted at least twice in 2021. Right, these are users who posted at least twice in 2021. Right, how do you confirm this information? If you do order by user ID, you see that each user will show up at least twice. Right, anybody who made just one post in 2021 is not considered in this analysis. Right, so if I do order by, just to confirm that information, order by user ID, there's a user ID indicating the person who made the post, and just run this. You can clearly see that yes, this is the same individual. Same, see, this person made 3 posts in 2020, 2022, 2 in 2022, then 1 in 2021. But this analysis is driving us to a particular direction. If you go, the focus is 2021. Right. Write a query to find the number of days between each user's first post of the year and the last post of the year. Number of days, we're going to see that function today. That's a date diff. The difference is to calculate number of days that has gone by from a start of an event to the end of the event. So I'll skip this question. We're going to come back to it. That's a date diff function, right? This, I'm going to skip this function. We'll come back to that. All right, but please take note, this this is similar to what we've seen today, right? But this one's extract datron, we don't have that in T-SQL. All right, this is a very important thing to note. All right, so please don't study this tutorial. It's gonna get you more confused. You will not be able to execute. For example, if I copy this and try to run your management studio, it's not going to go through because the way the calculations are done, the functions are implemented in a way that's different, completely different from what is done in SQL Server. Okay, so talking about number of days, I'll come back to this question when we study the dative function, right? Okay, any question? I'm just going to stop this process right here. We're going to come back to that, right? So let me go back to the class material. Let's see what we've covered. We've talked about the getDate function. We've talked about this and this are the same. I just know one of it. We've talked about these three important functions right here: year, month, day, right? And I want us to talk about the date name function, right? Let's talk about the date name function. But before we get to the date name function, this is just a repetition. This date part, this function right here called date part, right? It is simply a repetition. It simply lets you to go extract any part of a date. If you notice that the three functions we studied, they have direct extraction, this, and this. If I ask you to extract the hour, there's no hour function. See, minute, there's no direct minute function. So this left-hand side right here has direct functions. Year, month, day, they do exist. If in any case you're told to, which you rarely do, extract any of these parts on the right-hand side, the most often the focus would be on this side. They have direct functions to target. I want to extract year. Direct function is a year function. So these are what I put right here. Direct functions are on this side. These ones don't have a direct function. You cannot use hour to extract hour from the current date time. You have to go through the date part function, and then you put the part you want to extract, and then you put the date. This is very important. Minute, you cannot do direct extraction for the minute function, this one right here. You have to go through the date part function. So I'm going to skip that part and just leave it for review. All right, so this is the correct way to extract hour from any date. You're going to call the date part. It's a general function. You will now guide it by telling the function the part of the date you want to extract. Now you're being specific. I want to extract the hour, comma, and then you tell from where you want to fetch it. From this. All right, or I can just, you know what, let me just run to this stuff. Sometimes when we nest these things, students don't really appreciate it. But if you just put it out like this, run it, execute, then copy this value, and instead of putting that get date function, you actually code this value. But this is hard coding, right? So that you do one function at a time. So by putting this, this function is not useful, right? But I just wanted to know how you can extend that extraction to this side of the date and time field. These ones are straightforward, direct, because they have direct functions. These ones are indirect. You have to go through what they call the date part function. That's why I put no direct functions for these ones. You have to go through the indirect route, which is for the date part. Right? And that's exactly what I'm trying to document right here. So if I put this date right here, I cannot extract this like that. See, I'm trying to extract the hour. It's not possible. How do you solve this? Is to go through the date part function, tell the system you want to extract hour from this date. The system will now look through, and this is the hour. It's going to set to and return 11. Right. Please take note, for every other thing on this side, you don't have a direct extraction. You have to go through the indirect extraction, which is the date part. For these ones right here, they have a direct extraction, year, month, day. See? But I've not done any analysis where we are identifying the hour, minutes. Yes, this is popular quota. Give me all the sales, all the orders that were placed during the first quarter. If you're hearing quota for the very first time, I think I should explain that this quota here has significance in business analysis. Right. So this is the date part function, returns a specified part of a date. Right. And it is usually used on this side because they don't have no direct extraction. Right. It is needless to use it on this side. It's just repetition. You see, somebody will do this, but then this is a short form of that. See, there's no way you're told to return the year and you're using the date part, specify year to go do this. This is an easy way. These two are the same, but the second one is the direct extraction. Right? There's a direct function called year. Just go ahead and use it. Don't go to the date part. Go to the date part to extract these ones, not these ones. See? I'm just going to skip all of this. Now, what I want to dwell more is quota. All right, you see this a lot in business analysis. Sales that were placed in the first quarter. Let's compare first quarter sales to second quarter sales. First quarter, this is Q1, are sales that came from January, February, and March. You take all the 12 months in the calendar and you divide them in buckets of 4. The first 3 constitute what we call first quarter, Q1. The second 3 sets of 3, second quarter. This is third quarter. This is fourth quarter. You see? So October, November, December, this is Q4. See that? This is very important. Let me see if I can project this on an analysis so that you can see. So quota is very important when it comes to business analysis. And so there's no direct function called quota. You have to go through the date part, specify quota together. Show me the total sales generated in each quarter. Total sales generated in each quarter, order date right here. We've studied this function today, the year function. You see, it is going and extracting the year from the order date. You see, just the years are being shown. If I drill down, it takes me to quota. Date is hierarchical. At the very top of a date is the year. When you break from the year, that the next thing that comes in is the quota. So I'm showing you the breakdown of sales by year. The years at the top, followed by quota. First quarter, second quarter, third quarter, fourth quarter. So all the sales in January, February, and March, right here. If I'm not interested in the year, I can take out the year and just zoom into the quota. See that? This is very important. And if I click on quota, I expand, it takes me to month. This is now sales on a monthly basis. Right? This has a direct function. If I expand on that, it shows me sales on a daily basis. And this is exactly what we are studying right here. You will see this in Power BI, but I want you to understand that these date functions are working behind the scene. This is me visualizing my sales on a daily basis. Right. So there is no direct function to extract the quota. You have to go through an indirect function called date part. Right. And this is another alternative right here. So you can use abbreviations QQ. QQ means quota, or you can just go, if you don't like that abbreviation, you can just type quota right there, like what you do right here. So that's when the date part function comes in. You can use the date part function to extract any part of a date, especially those that have no direct extraction. Right. So this right here, this is January, February, March, April, May. So this belongs to, this is the second quarter. If you see in that classification, this is the fifth month. So we have 1, 2, 3, 4, 5. And this is the fifth month. It falls in quarter 2. So when I execute this, I get second quarter. This is important from a data analysis point of view. And this is where I'm going to recommend W3 schools. So for functions, don't use that website we've been using. Use the W3 schools. For functions, I think this is it right here. Let me share this. Control C. I think we need to take a break. But let me first of all conclude on this before we take a break. So these are SQL Server functions. If you just click on that link, and then SQL Server functions come in different categories. What we are currently at is the date and time functions. This is it, SQL Server date functions right here. These are examples we've covered. Right, we've looked at the year, we've looked at the month, we've looked at get date. This one we looked at day. This is what we're currently looking at, the date part. If I click on that, you're gonna see this is what I was demonstrating in Management Studio. You in the highest hierarchy on a date is year. When you expand on the year, you go to quarter. This is what they are showing you right here. The highest hierarchy on a date is the year. When you expand on the year, you go to quarter. After quarter, you go to month, and they're showing you the abbreviations. Right. So all of these can be extracted using the date part. You just have to tell the system the part you want to extract. And this is the syntax right here. The interval or the part of the date, and then you specify the expression. But for the ones on the left hand side, year, month, and day, please don't stress yourself. These three have direct functions. These ones have indirect functions, which goes through what date part. Right. I don't want to go too deep into this. Right. So if you want to extract the quota in an analysis, you cannot put quota and then you type out the expression of the date. There's no function called quota. The function quota does not exist. The only one that exists directly are year, month, and day. If you want to extract quota, you must go through the indirect function, which is what date part, and you specify quota and then you specify the expression. This is how you get to that. Right. So this does a great job in showing you the breakdown. So if you want to extract any of this, you just go through the date part. Right. Year has a direct function. Don't use this. Just use year on this. Month is a direct function. Just use month on the expression. Hour is not a direct function. Use date part. Yes, this is correct. You have to use date part. This. But don't go too deep on that. Just know the quota one. The quota is very important. You can see that in analysis. You're doing the, see, I'm breaking down first by year. You have the year. And then second, I'm breaking down by quarter. This is the sales, total sales for quarter 1. Quarter 1 has 3 months, January, February, and March. If you're seeing this for the very first time, you need to take a break and study this layout to understand how quotas are distributed across a given year. The first 3 months on the calendar, quarter 1. Right. So if you go back to that W3 schools, I want you to show me the sales that came in 2014. All orders that were placed in quarter 1 of 2014. Let me just make up a scenario. All orders, list of orders that were placed in quarter 1 of 2014. List of orders placed in quarter 1, first quarter. You can just put first quarter. These are typical business questions you can be addressing. first quarter of the year 2014. See that? And this is a point I am trying to make. Right, to get the quota, it is not a direct function. So you cannot go apply quota on order date. You cannot apply quota on order date directly. It's done in Power in visualization. You see, this is quota being applied to order date. You see, right here, this is a quota. All right, but then if you even look at it, it's a date part. Put the cursor right there. If you double click, it shows you it's the date part function. Let me go all the way to this side. You see, date part. That's SQL right there. See, and this is a beautiful thing. It shows like as if it's quota on order date. This is what I'm trying to type, quota on order date. But that's not the case. There's no quota function directly applied to a date. This is this is an error. And then we're just simply gonna put first quota as this equal to 1. This is quote. This is wrong. If you go into this visualization, double click, and then you see the actual code. It is a date part. You specify quota and then you specify the date. This is the function, right? The date part. See, this is very important, right? So I'm wasting my time if I want to execute this because the coding is wrong. There's no direct function called quota. You have a direct function for year. Please take note, these are the direct functions. Year, there's a direct function called month. There is a direct function called day. End of story. For any other part of a date you want to extract, use the indirect method, which is what date part. Date part. And then now you have to state the part you want to extract. So this function has two parameters. I want to extract what quota. Some people do QQ. That's quota. If you go to these W3 schools, you see that full list right here. What do you want to extract quota? You can put QQ or you can just type quota. Right. So if I type QQ, the system recognizes quota I'm looking for. I want to make sure that the quota should be equal to 1. And this is a condition you will use to extract only the sales that were placed, orders that were placed in the first quota. Right. Let me make this explicit by typing quota in full right there. Right. And then the second condition, which is mandatory, is that the year should be 2014. Year is a direct function. I don't need to go through date part function to extract year. Year is a direct function. I just put my year. See? So only use the date part function for those indirect parts of a date to extract. The direct ones are year, month, and day. The indirect ones are every other thing. Right. So I'm just gonna go directly year on order date and make this equal to 2014. Right. These are the list of orders that we place on the first quarter of the year 2014. For somebody who does not know first how to get quota, they might use the CRUD method by just knowing that these are the following 3 columns. No, sorry, these are the following 3 years that are part of first quarter. Right, so I'm just going to put, see, this is me coding in the funny way. I will use the month option and make sure that the month of the order date is one of these 3 listed. From the analysis, we've seen that first quarter involves what? The months of January, February, and March, first quarter. So since I'm using the month function, I'm going to put this as an in operator where month is in this list. I cannot type January, February, March. I can type 1 for January, 2 for February, and 3 for March. This is what you have to go through when you don't understand how to pull up the quota. See that? This is the CRUD method. But in the system, when you just put date part equal to 1, the system knows you're looking at the first quarter. And the months of the first quarter are January, February, and March. Let's compare these two analyses and see if they're the same. Run this. How many rows we get? 2,742. Now this is a crude method. 2,742. Same. Alright, so whichever one works for you. People don't really care when they give you questions like this. You use whatever you know, but it is important to know this how to extract quota. Quota is an indirect function. It goes through the date part function. That's the only one I'm going to isolate and talk about, right? Because it has business meaning. Sales of the first quarter, compare sales in quarter 1 with sales in quarter 2. You have to know how to extract those information, right? And this is it. So let me share this with you all. And let's take a break. Just copy that and put it in this segment. Yes, we're going to take a break, and after the break, we look at the date name function. It's similar to the date part, but in this date name function, you're going to be getting the actual names of the date part. For example, the actual name, January, February, March. Yes, we're going to see that using the date name function. Okay, let's take a 15 minutes break. I almost forgot your break. Let's take a 15 minutes break. After the break, we're going to have any questions you may have so far before we get into this new function called date name. Okay, see you after the break. Okay, guys, are we back?
I'm back. I'm back.
Okay. So, any question before we talk about the date name function? So let's see the list we've covered so far. So we saw get date and this other counterpart of the get date. Interesting ones: the year, the month, the day function, and we use the date part function to extract any other part of a date that is not this direct. These are the direct ones. Date name function is the next we're going to see, similar to this date part function, but then it is going to be projecting the actual name of a part of a date. It's easy to remember. It has a date name. See, for example, we saw that the month function will return an integer which corresponds to the month. But then what if you want to actually see the name of the month return? Right, you're going to go through the date part, the date name function. This is very important, right? So that's what we're going to see next. Right, so the date name returns a specified part of a date as a string. This is very important. So this right here is going to return 5 as an integer. See that? But then if you want to get 5, that's January, February, March, April, May. The fifth month is May. You have to plug that in a date name function. Tell the system you're interested to see the name of the month. Instead of giving you a 5, like what we get from this, it will give you the actual name of that month. So let me run this one so you see. You see that? So sometimes you're building a report and you actually want to show the end users the names of the month, not this one, but actually this one. Right. So now you know the transition. This is very important. This returns the name of, sorry, the integer which represents the month. Why this actually gives you the name of the month. Right. So if you go to those previous examples where we're talking about the sales of the month of December, you can use this and simply type December. It will go through. Right, I'm going to skip these other ones. They're not very important. Right, and I want to just draw your attention to this. When it comes to labeling, use the date name function because you get to know the actual name of the month. When it comes to sorting, use the month function. If you sort on this, you're trying to visualize alphabetical order A to Z. But if you sort on the integer, which is a number, you're sorting ascending, that's maybe 1 to 12, or descending 12 to 1, and that will achieve the order of the months as on the calendar. Let me switch this to 2022. Right, please do that at the end. Switch this to 2022. That's what we have. For example, let's retrieve the total number of orders and total revenue generated for each month. And in this, if you look at this, let me first of all check on this. I may have to change this year. This is 2022, so I don't think we'll have access to, okay, 2020, 2013. Do we have 2013? Yes, we have 2013. So this is the database we're looking at. And if you look at the question, retrieve the total number of orders. Total number of orders is simply going to be a count of the sales order ID. If you look at this table right here, each order has a sales order ID, which is unique. So you can count the number of orders by counting on the sales order ID. Right? That's how we're going to achieve that number of orders, by counting on the sales order ID. Right. So that's one metric. The next is the total revenue, which is what total due. Since we're looking at total, we are summing up the total due column to get total revenue. And then if you notice so far, what do we have right here? We have a month function on the order date. Right. And these two columns right here, this and this, are aggregated. Count, sum. This is a non-aggregated column. That's why we have to put it in a group by. If you run this query without a group by, you have an error. See that? So it is very important that although this is a function, yes, but it is not an aggregate function. So this is a non-aggregated column. We have to put it exactly as it is in the group by. And now this is what we get. So for the year 2013, we are showing you the total number of orders that came in for each month and the total revenue that was generated. Now, if you present this report to somebody, they will not find this funny, you see, because these numbers are integers. I will need to, it's not descriptive enough. So if you want to do proper labeling of columns, for labeling of dates, use the date name function. So you saw we use the month function, and this is not good. You see, I should be able to see September right here, March, December, and so on. Right? We are seeing the numbers because we use the month function. Right? But then what's the advantage of the month function? It works when you're doing sorting. For example, if I throw in an order by this, let's look at this. Sort by calendar order of the month. So this result is given to us in, we don't know the layout, see. But I want January to be first, so this should be 1, 2, 3, sorted nicely, and that's what we get. So you see, if I do order by month, this month right here is the alias is built from this. So this is an integer. You're sorting from 1 to 12, ascending, so smallest to the biggest, 1 to 12. You see what it gets? It mimics that nicely. You have to understand that month is the alias is built from this, which is a number. This returns a number, an integer. And now we've been able to sort the months in the order of the calendar, 1 to 12. You see? So that's why we say when it comes to sorting, use the logic which builds on the month function, the numbers. It sorts nicely. If I want to reverse this, I do December to January. I can just reverse that, you see, December back to January. You see that? So that is very important when it comes to sorting. So this is playing a good job for sorting, but it is not good for labeling. For labeling, you want to see the names of the months. So let's switch this alphabetical order of the months. I switch this now for labeling, you see. I want to see December right here, November right here, October, September, and so on, you see. I switch it to the name function, the date name function. The name of what I want to see is the month. I want to see the actual name of the month instead of the number, you see. And then let me just run this part first so that you see the change. Now I'm hitting my target, you see. I have January, you see that? This is good for labeling, right? Now, but then if you look at the sorting, see sorting, I am using this, which is built from the date name function. Sorting is not good when you use the date name function because if you look at the sorting will be done alphabetical order. Why? Because the system recognizes that this is a string. This function returns a string. When you sort on a string, it's alphabetical order. You're not going to get the calendar order of the month. So April comes first because it's A, August, A. Then we go to B, there's no B, you go to D, you see that? So when you're sorting on the month and you're sorting use the date name function, it's not a good idea. You get the alphabetical ordering of the months, not the calendar order of the months. So if you want to get the calendar order of the months, this is the conclusion, right? So we use this function for column names. It is appropriate in this case. The name of the column, the name of the values of the months will be projected, January, February, March, and stuff like that. But then when it comes to sorting, use this. This is an integer. Ascending will mean from 1 to 12. That's inherently from January to December, you see. So what's the correct way to do? This is the final solution. You see, for the name of the column, I am using the date name function. I will get January, February, March as values in that column. For sorting, see order by, I'm going for the month function. This is very important. That's what I want to draw your attention to. And this is how you hit your target. So I'm hitting my target in both directions. I'm showing you the names of the months through the use of the date name function. And then the months are properly sorted in the calendar order, January all the way to December. Why? Because I was making use of this. See that? So this is something I want you to pay attention to. Any question on this? So this is very important, and that's the only one I'll talk about when it comes to the date name function. Just the usage to project the actual names of the months. Don't use the month function. You get the integers. It's good for sorting, right? So 1 to 12, right? That's the meaning of ascending, and by so doing, you're getting the right sort process January all the way to December. All right, this is an interesting analysis. I'm showing you each month, the total number of orders that came in, and the total revenue generated. So that's an interesting analysis you can do, right? And again, you're familiar with this. The condition, this analysis was based on 2013. Let's go back to the question right here for each month in 2013. So on the order date, you have to use the year function and point it to 2013. Right. Any question on this? This one, I'm going to skip this one. You can read it when you have time. Anyway, maybe I just mentioned this person. This right here is a weekday. It's just the days of the week. Right. So for example, if I tell you to give me the orders that we place weekend. So in this analysis, the first day of the week is a Sunday. Right. First day of the week is Sunday. If you look at this right here, this is today's date. Now give me the weekday for today's date. This is the investigation right here. Today is a Saturday. We're getting 7. So SQL Server is built such that the week begins on a Sunday. So tomorrow this result will be 1. We're getting 7 today because it's a Saturday. So the week begins on a Sunday, which is the weekday 1, all the way to Saturday, which is weekday 7. So today we're in Saturday. You see, this is getting today's date. And then this is getting the weekday for today's date. Right, it's gonna be 7. So if you're asked to get orders that we place over the weekend, you simply use a date part function weekday on the order date. In this, if it came in on Sunday, 7 Saturday, these are orders that we place over the weekend. So list of orders placed over the weekend. This is it. So you're using the weekday date part function point to weekday 1 and 7. See, I have to switch the database. This is not win. We are investigating the list of orders that we place over the weekend, right? And this is what we get. No order was placed over the weekend. You can use the sample superstore, the global superstore orders table, and investigate this. For example, let's see list of orders placed over the weekend. I'm just going to copy this, and since this is global superstore, put it right here and transform this list of orders placed over the weekend. You just have to remember that you're going to be using the date part function. I'm just going to modify this date part function here. Is weekday. Yes, weekday is the option, and then we are looking at that based on the order date. So go to the order date column, return the weekday part of the date, and if this is in this list, 1, that's Sunday, sorry, and then 7, that's Saturday. Now if you run this, you see that all of these orders came in during the weekend. The day, what did I use? Order date in 1,7. This is the year, the month, the day. What am I seeing right here? 8. Now this does not seem correct. Let me narrow this down to the other ID. I want to see what's going on right here. Other ID is and the order date. Okay. Okay, so visually this is different, but you have to understand that this right here is the year, this is the month, this is the day. Right, so what the system is, although it's showing you 8 right here, you actually have to go to the calendar to see if this fell on a week. This right here is weekday. This is day. Day 8 is different. This is 8th day of the week. 8th day of the month, sorry. 8th day of the month of January. Right, but then what we are looking at right here is the weekday. It will be best if I project this as a new column. I'm going to add it right here so that you can see. This is a little bit confusing because we are testing this output using weekday, using day instead of weekday. So the best thing to do is to add weekday as a column so that you see the difference. So if I run this, you see, although this is misleading when it points to 8, this is the 8th day of the month of January. Right, but then weekday is staying within a week and investigating if it's a Monday, Tuesday, Wednesday. Right, you understand that better when you go to W3 schools. It has a nice breakdown of this concept right here. So we're looking at what right here. So it goes within a week and finds out if that day was on a Monday, a Tuesday, Wednesday, Thursday, and so on. So it's different from the day. This is tied to the month. So today is the 17th day of the month of February. It is different from the weekday, right, which is 7, because 17th of February falls on the 7th of the week. Right, so these are two different things we're investigating. So it could be misleading when you just analyze this result by pointing on day. We are not looking at day 1 or 7, no. So that's why I had this confusion on 8. When I saw 8, I see 15. This 15 simply means it falls on a Saturday. But this is the 15th day of the month of January of 2011. And this day happens to fall on a Saturday. Just like today, today is the 17th day of the month of February. And it happens to be a Saturday. That's why we get a 7 right here. So there's a difference between weekday and day. If I switch this to day, it is now different. See that if I run this, I can now evaluate this result by looking at this. This is day. So each of these will be either 1 or 7. In this case, this is strict implementation. Why this is showing us what? Let me go back and knock off this. So now this is looking at orders that came in on this first day or the 7th day of the month. See, this is now you can use this portion to validate your result. This is the first day of the month of January of the year 2011. This is the 7th day of the month of January of the year 2011. But when you switch this to weekday, you have to be very careful in the way you interpret it. So that was the confusion. I had to, look at this closely, and then you can always feel free to add this as a separate column to test that logic. Right. So you see that this day right here happens to fall on a Saturday. That's why we have 7 right here. This day happens to fall on a Saturday. Right. If I just switch this to what? Name. Instead of giving me 7, it will give me the name of the day. See, that's all you need to do. Date name. If I run this, let's do it on this side. Now, since if I do it like this, I have to change this to what? Sunday, change this to what? Saturday. See? Because if I run this, you're gonna get an error. Date name is giving you the names. So 1 corresponds to what? Sunday. So you have to change this to Sunday. See that? And then 7 corresponds to what? Saturday. You have to change this to Saturday. I don't want to go deep in this. These are not things you see in analysis. Right? And then you have to do the same on this one. Let's change this to what? Date name. Right? And now if you run this, we are looking at the same question like before. See? Now, but you're getting the names of the weekday. Please don't go deep into this. The key ones to focus on are the year, month, and day. We only go to date part because of quota, because there's no direct function called quota. You have to go to date part to get the quota. Right. And then we focus on date name on the month function. Sometimes in your report, they want you to show the actual name of the month, like the analysis we did right here. That's the only reason why we went to the date name function. This analysis, show me each month and tell me the number of orders that came in and the total revenue that was generated. Right. So in this case, we are showing you, we are interested to see the actual name of the month. That's why I took you to that direction to know the date name function. And it's easy. Each time you see name, date name, you're projecting the name of whatever part you're targeting. This is very important, and that's how you get to this. See, it's much more better like this compared to what we did here, or no, what we did right here when we are just showing the integers. You see, you're giving somebody a hard time to read this, right? So please focus mainly on these ones right here. These are key functions that you have to know. These ones, how to get the current date and time, of course, get date. And the last 2 functions we're going to focus heavily on will be these 2. These are 2 analytical date functions, the date diff and the date add. From the moment you place an order to the moment the order is delivered or shipped, how many days in between? That question is solved using the date part function, a date diff function. And you're going to see that in a lot of questions that have an order date and a ship date. The order came in on this date. The order was shipped on this date. How many days between the order date and the ship date? There is an interesting analytical function called date diff. The word it says diff, the difference between 2 dates. There's a date add, you're adding a quantity onto a date. I want us to go over these 2, right? And that will be the end for date time functions, and that's the focus for today. Let me go back to the notes and see what we have. Please, any questions, just stop me and ask. Yes, now we are ready to embark on the date diff function. This word should just give you a clue on what this function is doing. Difference between 2 dates. You have a start date and you have an end date. And now this is going to trigger so many things when it comes to calculations involving dates. And that's why I keep telling you, you cannot build a database and store age. Age keeps changing after every year. You see that? So what you should rather do is capture the birth date, and then giving your birth date at any given moment, I can calculate your age to using what date diff function. So whenever you hear date diff, it's simply the difference between 2 dates. There is a start date and there's an end date. How many days have gone by since this event started all the way to the end of the event? And you can calculate it in days, in months, in hours, in years. You have to quantify it. That's what we put this right here. This simply quantifies the calculation. 20 cocoyams is different from 20 plantains. Of course, 20 years is different from 20 days. So you use this parameter right here to quantify the calculation. Of course, this is your start date and this is your end date. And together, these are the three mandatory parameters the dative function needs to do its job. The goal of the dative function is to calculate the duration between two events. There must be a start date, which is what we call date 1, and there must be an end date, which we call date 2. And then this right here quantifies the output you're projecting. See, for example, I want to look at the number of years between these two dates, this and this. That's how you're going to read this function. So when they give you something like this, can you read this and explain it to us? This, you just simply target this. Yes. So we're looking at what the number of years between this event and this one. That's what the dative function is doing. This is an easy function to remember. Dative, difference between two dates. You must have a start date, you must have an end date, and then you must quantify the result. So if I now execute this, you now understand this is not 6 hours, this is not 6 days, this is not 6 months. This is what 6 years. This is what quantifies that result. This is very important. Right? You see this a lot in businesses. Right? Hope we understand this. If I take you to W3 schools, let's go to that website, and I want you to study alongside that. This is a dative right here. Dative is right here. See, returns the difference between two date values, and then you quantify it. If you put in years, then you have to put year right here. So this is the start date. Don't reverse the order. If you reverse the order, you get a negative value. So ask yourself, what is the start date? You put it first, and then this is the end date. You put it second. This is very important, and this simply quantifies the result you get. Right? And this is it. This is the syntax right here. And with this, you can solve any kind of question involving tracking duration to events. This right here, want to calculate the number of what hours. Why do I say hours? Because of this. The number of hours between this date and this date. See that? That's it. Very simple function, right? You should not get this confused. From the name, you can tell what this function is doing. You must have two dates. One being the start date, date 1, and the other being the end date, date 2, and you must respect this order. And then you quantify the result. I can put this, see, this one is tracking the number of years between this date and this date. This one is tracking the number of months between this date and this date. This one is tracking the number of days between this date and this date. They're all different. And if I run this, you have to understand. See, this is 6 years. Why? Because this is it. This is 72 months. This is what? 2,192 days. Right? And basically what this function is doing is simply going and focusing on the date. All right, this is what you and I will do. We take the bigger one minus the smaller one. But in the coding, you start with the lower one, the start date, end date. So always remember the syntax. It is this is the start date. I think if I document it like this, it will be understood. This is the start date. Always remember any event. I have student information, I have their date of birth, I want to calculate their age. The start date is when they were born, and the end date is today's date, for example. And now you understand that there's a today's date, which is the get date function. In fact, let me take you to an example so you can see. This is exactly what I'm explaining. We go to academia as a student database. We want to compute the age of each student in years. They always tell you the quantity, right? So this function will be the interval, which is what is stated in the equation, that's years, and then followed by what? The start date and the end date. The start date is when the student was born. That's where you're going to begin tracking. And the end date is what? Today's date. So this, in this case, the interval is what is given the equation is year. This will be the start date, which is what? As per the information in the database, this is the date of birth. See, that's going to be the start date, right? And then the end date as of today's date. How many years is that particular student? That is the end date as of today's date, right? And we're going to make this process dynamic. Instead of finding today's date and plugging it right here, you've made that process static. So let me show you the two outcomes. This is a dynamic process, and that's what we should advocate. And then this other one right here is static, where you simply find today's date and you hard code it. So static, it's simply gonna be us finding today's date. In a static approach, you wouldn't need this, right? And I want to discourage this practice. I just simply go in there. Today is February 17. You see, right? Tomorrow or next year, this will be invalid, right? Because I've hard coded this, right? So for the meantime, you will get the right results, right? But in the near future, this will be giving false results. See, so this is a static approach. See, so this is where the calculation is taking place. We are using the dative function. We're told to calculate in terms of years. So we put the year right here. And then this is the start date. That's the date of birth of the student. This is the end date as of today's date. See, I don't want to advocate this strategy, so I'll rather talk about the dynamic one. As of today's date, we are using what get date. This calculation will be valid forever. Unlike this one, next year or in a couple of years after, this will be invalid. You see, this one will always investigate today's date, and then now it will use that start date all the way to today's date. And this is a dynamic process. And this is what we get. You see that? So please take note that the dative function returns an integer. This is also one very important thing, because you're going to be looking at the date at function, and they always ask you in interviews what's the difference between the dative function and the date at function. Right? You can explain the difference from the definition. One is taking the difference between two dates. One is adding or subtracting a quantity from a date. This, let's begin with this one. This is the difference between two dates. If you take a difference between two dates, it can never be a date. So the return, this returns an integer, a number. And if you get this confused, always use your age, for example. To calculate your age, you will need a dative function, date of birth, and today's date. That quantity will be an integer, not a date. The outcome of a dative function is not a date, but the outcome of a date at function is a date. Add 5 years to today's date, you get a date. Right? Take a difference between two dates, you don't get a date, you get an integer. That's something very important to remember. Right? So this is our very first example. We have date of birth, and we are looking at the age of each student. Our start date is date of birth, our end date is today's date, and we're calculating this in terms of years. So now you see this output. This 34 means 34 years. See, and you can quantify this is age in years, as Elias says. See, that's one example. Now, only show students above 30 years. This is just a scenario where we take the logic for calculating the age, which is this, and we plug it in the where clause. See, this is it. This is a logic, and we make it greater than 30. This is a common mistake students do. They take the alias. Yes, this alias, and they put it right here. You cannot use an alias in the where clause. It complains. Aliases are allowed only in the order by. You see, age is an alias. I'm using it in the order by. It's good. Age in years is not. It's an alias. I cannot use it in the where clause. Right, so you have to use the logic behind that process. Right, this is giving us every student and their age. 32 students in total. This is giving us only students that are above 30 years. Why? Because of this condition right here. You see, this is a calculation greater than 30. Don't copy the alias. And you see students make this mistake. They copy the alias like this together with the alias, the AS keyword, and put it right there. This is an error. You are fetching only the logic. This is how age is calculated in years. Copy that and place it in the where clause where that expression is greater than 30. It is this expression right here which is generating that age in years column, this one. So to get students who are more than 30, use that expression and put it in the where clause like so. Now if I run this, I'll get only students that are more than 30 years. And if you look at the list, every single one of these students is more than 30 years. This is very important, you see. So always remember, it's a simple function, date diff. It is used when you want to calculate the difference between two dates. Mostly in duration calculation, there are two events. This event starts on this date and ends on this date. What's the time interval between the two events? And they'll always quantify it for you so that you know how to code it in years, in months, in days, whatever. Right. Please tell me if you have a question. And let's check out one more. The employees, of course, we're going to be looking at hire date. And we're going to be looking at the duration in the company, how many years an employee has been in the company. Every employee, once you're hired, there's a hire date. We know the date you joined the company. And some companies celebrate these milestones, 5 years in the company, 10 years in the company, 15 years and stuff like that. And they give some bonuses. How do they track that? There's a date diff function, right? We want to calculate the duration of the company in years. So we put year right here. Start date, when the employee was hired. That's a hire date. We are calculating this duration as of today's date. So we use the get date function to fetch that and make it a dynamic process. And then we are creating a new column. We're going to call it duration in company. And that's it. So for each employee, we will be calculating that duration. This employee was hired in 1990. As of today's date, 2024, we track that information. Right. So you mostly use the date diff function when it comes to duration calculations. Businesses do this a lot. Track certain metrics. Right. It's a start date and an end date. And you want to look at the duration. It could be in years, in months, in days. Right. Now, duration in the company in years only show employees who have been in the company for less than 25 years. It's just like what we did above. This is a where clause. Get the logic for calculating that duration and make sure your duration is less than 25. And adding that condition, this is what you get. Right, so all of them have been in the company for more than 25 years. This was the first thing. So yes, all of this is more than 25. Right. Take a look at this one. Duration of the company in months. It's the same calculation, but we're just changing months right here. So we're looking at the time interval from the higher date all the way to today's date. And that will be the duration of the company in months. This values will be larger. This is 398 months. See, that's not years. So remember, in the syntax, this quantifies the result you get. All right. Now let's look at an interesting example. Average duration in the company in years per department. So show me each department, that's the department name, and then calculate the duration of employees in that department. Right. So I will need the employees table. I need to join it with the department table. Right. From the department table, I'll be getting the department name. So there are two tables involved in this question. I first of all start by joining them. One table, we're gonna get the department name, and we can only get that from the departments table. The age column is found on the employees table. So there are two key columns in this analysis. The one we're going to be computing the information on the age. To calculate age, we need the hire date, which we'll get from the employees. See, that's why we need that column. Hire date is stored in the employees table. Right. Now we want to calculate this per department. Department is not found in the employees. We want to show the names of the department, so we need the department table. So department name, we have finance, audit, marketing, production. What is the average age of employees in the finance department? Average age, or not duration, this is not age, this is duration the company. Average duration the company in years. So I'm showing you each department. So after joining these two tables, there's an investigation right here. It's going to be based on department ID. You see department ID right here on the employees, department ID on department. So you join the two. And what did they use? They use a right join. So right join simply means you're prioritizing the table on the right hand side. So you're showing all departments. Right. So this is it. So date diff, we start with the higher date and all the way to today's date. How many years has this employee been in the company? This is very important. So department, then the duration, right? And this is what we get. See? But then this is not the final solution. The final solution says that show me each department. You see, in the audit department, we have this number of employees in the audit department. What would be the average age for employees in the audit department? It's going to be this, plus this, plus this, plus this, plus this, divide by 5. That is the meaning of average duration in the company. These are all the employees in the audit department, and these are their ages calculated. What will be the average? You have to add up all of this and divide by 5. That's for the audit. In the finance, these are employees in the finance department. You have to add up all these ages and divide by 3. Marketing, these are all employees in the marketing department. You have to sum up these ages and divide. You see that? This is very, very important. Right. Why is production showing up right here? Because we are doing a right join. Right join simply means we are showing all departments, whether or not they had an employee. If I switch this to an inner join, the production department will go away. There's no employee in the production department. This is the best case for an inner join, so that we are tracking. See, the production goes away. See, I think switch to an inner join so that we only look at those departments that have employees. Inner join. Right. So this is just the first step. This is not the final solution. In the final solution, we now have to group by each department while performing aggregation on the calculation we did above. This was the calculation for the age. To get the average age, you use the AVG function on that calculation. Very, very important. And sometimes when you're dealing with many parentheses like this, it gets confusing. If I dismiss one of these, you get an error. Right? How do you know that your number of parentheses are not balanced? Count the number of open ones. This is open 1, this is open 2. This is another open 1 right here, 3. And then count the number of closed ones. This is closed 1, this is closed 2. So I'm missing 1 closed in order for it to be balanced. Or better still, to avoid this error, this is what people do. Just remove this. What are we calculating? We are calculating the average duration. So this is the logic right here. Copy all of that and just paste it inside. This is duration in the company. When you copy that expression and put it right here, it becomes what? Average duration in the company. And you see it's clean, neat, no error. Right? And we are showing it for each department. Now this logic has been aggregated through the average function. This is a non-aggregated column. It has to go to the group by. Right, so now we are showing each department, which will occur only once. Why? Group by. And then we see the average number of employees in it. I kicked out production by simply switching this right join to inner join so that we are only looking at those departments that have employees. Production is the department does not have any employee. Right, so if I switch that to inner join, it goes away. So this right now is the average age of employees in each department. It looked like a very simple question from the very beginning, but then when you start solving it, you notice that, hey, this is just the average duration. This is just the duration, sorry. We have not averaged on this. We're just showing each department, and we are showing you the number of the duration of each employee in the department. Audit has 5. So averaging will mean sum up this and divide by 5. And that's what you get when you now put that logic inside an average function. You cannot memorize this. You have to understand what is going on, right? And then you code this gradually, right? So now this is what is referred to as the average duration in the company. And we are showing it for each department. There are multiple employees that can be coming from the same department. So how do we do that? We group by each department, and this is it. Right. This right here, we don't have access to this while importers. I'll just want you to switch this to anyway. I'll just keep that. You can go over it, but I'll create a different one. Let's use the global superstore. I'll set an example using that same logic for the global superstore. In the global superstore, the manager wants you to generate a new column called order duration, right? Right. Order duration should be computed in days, and this is the calculation. It should be the difference between the order date ship date and order date. So ship date, I want to use columns that we have in the table: ship date, order date. So if you go to global superstore, right, there is this table we're going to use called orders select star from dbo.orders, dbo.orders. And first thing, check to make sure you have access to those columns. This is the order date, and then this is the ship date, right? So for each order, so for example, the information we can track across each order, let's just track like the order ID, right? So for each order, let's show the following information. Show me the order ID, right? Show me the order ID. Show me the customer ID, right? Then show me the order date, order date. Order date, show me the ship date. And then now we get into that duration, right? Let's change this to, let's call this the shipping duration. That will not be the other duration. This is going to be the shipping duration, which in this case, we're going to define it as the difference between this and this. And you have to watch out when implementing this, you have to know the order of the events. So this is an example of difference between two dates, and you know that we use the date function in SQL to investigate that duration. And we are told to capture this in days. See? So I'm going to put day right here, put a comma. From the business process between ship date and order date, which is the first? Which one comes first? You have to know that business logic in order to code it nicely. If you just go right here and plug the ship date as your start date, that's not correct. You're going to have some funny you start having negative values. If you start with ship date followed by order date, right? This is not, you're not respecting the business process. If I run this, you can start seeing negative values. See, that's just a direct interpretation of this. But then the date diff function has to rely on the order in which the dates come in. So start date is the order date. It's the date the order was placed. That's your start date. So from the date an order is placed, how many days does it take for it to be shipped? That's what we call the shipping duration. Right. So this is very, very important. And now you see those negative signs go away. Right. So the order in which you place those dates matters. And this is what we call the shipping duration as per the definition in this question as the shipping duration. Right. Simply the number of days it takes from the moment an order is placed to the moment the order is shipped. How many days? And this is it. You can use this business metrics to compare two different companies on their performance. How fast do they react when an order is placed? Maybe Amazon and eBay. From the moment you place an order on Amazon, when do you get the shipping information? Right? You can compare those two. Right? Every shopper is interested to buy a product and that product gets delivered. We don't have a delivery date. We would have talked about that. If you look at this table, we just have an order date and a ship date. We don't have a delivery date. Right? If we had a delivery date, that would be the delivery duration or some other metrics we can track. The duration, full duration, that's from the moment you place your order to the moment it's delivered. How many days, how many minutes, how many hours, right, did it take? Right? And this is it. So this is a very simple function. It's used whenever you want to look at the duration between two dates. And this duration gives you a number. It is no longer a date. The difference between these two dates is not a date. It is a number, an integer. And that's why when you put your cursor right here, it tells you that it's a built-in function, dateDiff. It takes an interval, which is in this case is day. It takes a start date. In this case is the order date. It takes an ending date. In this case is the shipping date. And then it returns to what? Returns an integer. See, they put that word returns in uppercase, integer. So this function will not give you a date. It will give you a number. And that number defines the duration between the two dates you have as parameters. And you can quantify it using this one. So this right here, there are 5 days have gone by from the moment this order was placed to the moment it was shipped. See that? All right. And let me add one more thing to this so that we can. There's something called the ship mode. This is ship mode. The ship mode, it would just, if we had a delivery date, it would make a lot of sense. You just run this. So you see that this use the standard class. I don't know about the shipping company standard class. How many days does it take for a standard a product that is shipped through standard class? First class, there's also what we call, I think this is same day delivery, same day. So this is more like on the delivery side. Yes, this is the date the shipping was done, but then same day delivery. If we had a delivery date, then we can compare. See, you see that this is actually the order was placed on this date and the shipping information was available. It was shipped on this date and that's same day delivery. So this ties with what you're seeing right here. Right. So usually when you go to ship a product, they'll ask you what shipping mode you want to use. And of course, the fastest one is the same day and you pay more. And in this first class, I don't know the number of days that are, but then of course these are different shipping modes and you pay more depending on how fast you want the product to be delivered. Right. So this is something to watch out. Diff is a very important function. It's very simple to remember. You have two dates and you want to look at the interval or the duration between them. And if you're tracking this in any business process, that's what we call the date diff function. You must follow the workflow or the business operation. Which one comes first? Between order date and ship date, which one comes first? So that you don't reverse the order. If you stipulate ship date, then order date, you get negative values, which is just a distortion of the business process. See what you get. You see negative shipping duration. This should not happen. So take a moment and understand the two dates you're giving, which one comes first. An order date has to be first, then the shipping date is ready when the product is ready to be shipped. You see, so this is the start date and this is the end date. You're now looking at the duration between these two. Any question on this? In fact, let me just copy this and share with you all. So we want to generate a new column called that. So the calculation is going to be given like that. It doesn't mean you're going to take this in this order and just plug it. You have to ask yourself between ship date and order date, which one comes first? And you need that information so that you code it correctly. Let me share this. I'll pause for a while so that you can take a look at that before we go to the date add function. While you're looking at that, let me just go over some other databases. I want to see if we have some kind of duration information we can fetch. I see a project management database. Let me use project management. So this is a database that shows projects and the different managers working on them. There should be a start date for the project, end date, and stuff like that we can explore. Let me see how true that is. So the schema for this is Galactus. Yes, this is another example. We can use the project management underscore SQL database, and I just want you to show me each project. Just show me each the duration for each project. We have the start date and the end date. Each project duration. Let's just compute a new column called project duration. Compute a new column. So from the name, you understand that it's the difference between the start date of the project and the end date. And that's an easy project we can achieve using the date diff function. So this is an example of a date diff function. And once you explore the content of that table, this is what we have right here. The moment you see a start date for the project and an end date, that's fine, right? And I can even make this more interesting. Let's get each manager and the number of days spent on each project. So now I'm bringing in the manager information. So it means we have to join, right? We have to join this to the manager table, right? Because to get the names of the manager, you need to get the manager table, right? Then to get the duration of the projects, you need that from the project table. So for each project, I'm interested in a couple of columns. So first thing, we have to join these two. What column are we going to use to join? We have manager ID on the manager table. We have manager ID on the project table. Excellent. Right, just show me the two together. I'm just going to start by joining this. Let's just use an inner join so that we focus only on those managers that are assigned to projects, right? So this is what we're going to do. This is an opportunity to review the joins. So take the manager table, join it with the project table. There's a project table right here. Remember, it is a project table that has the start date and the end date. And then we need the manager table to show the names of those managers. Right, this is the project SSP. Now on the on clause, from the manager, we are taking the manager ID equal to, on the project, we are taking the manager ID, same, is towards the bottom, but it's manager ID right here. And this is the join between those two. Right. So show me each manager, the project they're working on. So for each manager, that's first and last name. Yes, you can just combine first and last name, or you can just put them separately so that we don't get confused on this. First name, last name, let's put them separately. So for each manager, show me the first and last name. Yes. Show me the project ID they're working on, and also the project name right here. Right, then show me the start date of the project. Show me the end date of the project. And then this is now where we can calculate that duration. But before getting to duration, just show me the status. I want to put one column right here, the status. Anyway, let's kick out the status. I think this is fair enough. Now, this is where that calculation comes in. So the project duration, let's compute this in days. Compute in days, right? So for the project duration, this would be a job for the dative function. Dative, where since we are told to calculate it in days, the interval right here, you see the dative function requires 3 arguments or 3 parameters. The first one is the interval. We are told to do it in days, that's day. The second is the start. So date 1 is the start date. This is when the project began. And then date 2 is the end date, when the project ended. We don't need to use a get date function because from the table, we have those information stored in 2 different columns. When the project started, when it ended. And so this will be the end date, the end date right there. Right. And so this, if you execute this, it is showing you each manager, first and last name, their project ID, the title of the project, the start date and the end date, and the number of days. Let me switch this to months. Yes, let's switch this to months. Compute in months. Right, I'm gonna go right here and switch this month. Right, let's run this. You see, there's a problem right here. This manager has a project which started on this. So there's just an ended. See, this is a typo. It's an error. You can even spot an error. A project cannot start in 2022 and ends in 2013. This is an error. So as a data analyst, you can see this kind of errors. You can just call the attention to those who are in charge. And this could be maybe it was supposed to be 2023 and the typo they put 2013. So this is wrong. A project cannot start in 2022 and then gets completed in 2013. See, just by knowing what you're doing, it shows a red flag right here. See, so you can draw the attention to the project owners and say, hey, something is wrong on this project. Can you check the end date? Right. And that's how you draw attention to business owners. You see, that's a typo right there. They can fix that. They can tell you to ignore that or fix it, update it 2023. I'll show you how to do an update statement right at the end of the training. Right. So that's it. I think that's the only red flag we saw right there. So this is it. Right. This is another example of implementing a did function. Right. Let me stop right here and I'm going to share this, the full script, and put it right here. And I'll pause for a couple of minutes so that you can check that out. I forgot to put the name. That should be project duration. We're going to put it right here as project duration. Right. And this is it. Yes. So we've done two separate ones. I think I forgot to, yeah. So this was one. Other duration, yes, we solved this one from Global Superstore. And then this is another example. Just add it to that main document under date function. This is more example, and make sure you click on the save button. So the first one we did was on Global Superstore. We're looking at the duration between order date and ship date. I think I shared that one on the chat window. Yes, just make sure you update. That's and then the second example is the one that uses the project management. We're showing each manager the start date, end date, and we're computing a new column called project duration, which is looking at the number of months from the start date to the end date. Nice. Yes, let's take a pause before we get into the date add function. I want to pause for like 10 minutes. I'm going to project a 10 minutes break. Let's take a 10 minutes break and then we're going to come back for the last part, which is the date add function. This will give you some time to catch up on that concept of date diff, and we can address any questions after this small break. Let's take a 10 minutes break. Okay, see you after the break. Okay, guys, are we back?
Yes.
So let's conclude this with the date add function. Right. And take note, this is adding or subtraction. I'm going to show you where the subtraction part. So there's nothing like date sub. Right. Date add will perform an addition onto a date or a deduction from a date. Right. And let's see some scenarios on that. So this is the date add function, adds a time or date interval to a date. And of course, this returns a date. If I add 5 months to today's date, it will be a date. See? So return the date of end of contract, given that each contract has a duration of 2 years. So if you're looking at the employees, let me switch this to this employee database. We are looking at the employee stable. Let me just project this so that you can see. Right. So most of these IT jobs, some of them are contract based. You can be hired for a 6 months contract, a 12 months contract, 1 year, 2 years, and stuff like that. Right. So let's just pretend it's a contract. The duration is 2 years. We know the hire date. So end of the contract will be what? At 2 years onto the hire date. This is different from a date diff. This is not a date diff scenario. So you have to know when to go for the date diff function and then when to go for the date add function. Right? The employee was hired on this date. Add 2 years onto that date to know the end of the contract. Contract is valid for 2 years. From the moment you're hired, 2 years added to that, you get to know the end of the contract. See, so this is an example of a date add function. Right. So the syntax is a little bit different. If I take you to W3 schools and you're looking at date add function, you're adding a quantity onto a date. If that quantity is positive, then it's an addition. See, this is an addition right here. We're using the date add function from additional deduction. So it would have been redundant to do a date sub function. There's no date sub function. It all depends on this quantity right here. And this quantifies that number. This is 1 year. So we are adding 1 year onto this date. If this quantity is negative, we are still going to stick to the date add function. In this case, the interpretation is we are deducting 1 year from this date. So this is something that should be clear. Right? Date add will do both addition and subtraction, depending on the quantity specified right here. So this date add function, it doesn't take 2 dates. It's unlike the date diff function when you have a start date and an end date. You're simply taking a quantity and you're either adding or deducting it from a given date. And that's the whole foundation of the date add function. Right. So you just have to understand that layout and you can now use it to solve a lot of business questions. So we are going to the higher date and we are adding 2 years. Why 2 years? Because the contract duration is 2 years. And we want to know the end of the contract. So that's a new column we're going to generate. If you were hired on this date and your contract lasts for 2 years, when will be the end of your contract, right? So the maturity date of that contract is just going to be a new column which will be calculated by adding 2 years onto the higher date. And that's the job of the date add function right here. And this is very important. You see that we are adding 2 years onto the higher date to get to this. So notice what it's doing is keeping this and this same, the month and the day same, and it's just adding 2 onto the year. See, this and this is the same month, same day. So we are just attacking the year function, the year part of the date, and we are adding 2 onto it. See, that's why this information is very useful. You can add 2 months onto a given date. So you have to document this properly. You have to read the question carefully and know which part of the date will be impacted. See, right. So this is it. You see that the day and the month part stays the same, and we are simply going to the year component and we are adding 2 onto it. See that? And that's the job of the date add function. If this is negative, you're deducting 2 years from the higher date, right? And that's still a date add function, but now you're deducting, you see, this is a deduction, right? So in this question, we needed to add 2 years onto the higher date to get the end of the contract right here. Any question on this? So you can clearly see that the date add function returns a date. This is the output of the date add function. It is a date. The date diff function returns a number. See, this is a date diff function. We're looking at the duration, number of months between this and this. Right? This is going to be an integer. This is very, very important. So if you're asked to, in an interview, the difference between date add and date diff function, yes, there's a lot of possibilities you can explain. One of which is the type of data return. The date diff function will return an integer. The date add function will return a date. This is interested in looking at the duration between two events, the start date and the end date. This is simply adding or deducting a given quantity onto a date. And the quantity can be in years, in months, in days, and so on. Right. Let me see if there's any other example. Return the date of the end of contract, given that each contract has a duration of 9 months. So we've moved from 2 years to 9 months. This is a very important part of that question. We are simply adding 9 months onto the higher date. See? And this is what we get. So in this case, we are targeting the month and we add it. And so it may take us to the following year. And so you notice that the day seems to be fixed. Maintain it's not impacting the day, but then it's going to affect the year if it moves to the next. This is already the higher date. This is already the end of a certain year. Now add 9 months onto that. Of course, it will take you to the following year, and that's, you see, right. This one happens to stay in the same year. This one was, you see, right. So these are things that you have to know. Difference between the date add function and the date diff function. Right. This is adding 1 day onto this date, and that's the outcome right there. This is deducting 1 day. See, the presence of the negative tells me it's going to be a deduction process. Although it reads date add, right? The student once asked me, why is there no date sub function? It doesn't exist because they understand that the difference will just simply be on the sign, right? So date add is doing both addition and subtraction, right? This is adding 1 year onto this date. This is adding 1 month onto this date. This is deducting 20 days from this given date. And in all of these scenarios, what do you notice in the outcome? It is a date. The outcome of a date diff function is a date. The outcome of a date, the outcome of a date add function is a date. The outcome of a date diff function is an integer, right? That's something very important to remember. Let's just do some arbitrary scenarios which will help, drive this message. An employee is 40 years old as of today. Find his or her date of birth. So you're going backwards. If today the employee is 40 years old, let's get today's date. This is today's date. Let's go backwards from today's date, 40 years into the past. It will take us to the date this employee was born. It's a simple investigation right there. See, now you have to understand why we have a negative right here. So we're going 40 years backwards from today's date. If today is your birthday, you turn 40, deduct 40 all the way back. It will take us to their date of birth. They were born on this date. Then alternatively, you may be given this date right here. Let me copy this and just put it right here. You may be given this date and you're told now to find their age. Let me remove this timestamp. We don't really care about the timestamp. So if the date of birth is equal to this, find the age. This is an example of a date diff function. right? The start date is this date right here, this date, and the end date is today's date. So given that we were born on this date and this is today's date, what's your age? That's a job for the dative function because we are dealing with two dates and we want to look at the interval between them. Dative, we are returning an integer. Right, this is very important. Right, you can just change this to 2022. Right, yeah, I'm just gonna skip this. This is just repetition. So for this one, just change them to 2022. You can go over those ones. We have a couple of minutes left. Let me see if I can go back to those examples. I will come back to these examples during the lab. Right, this examples right here. Yeah, we're gonna touch base on some of them during the lab. Then SQL. So today we've seen the date functions. This one right here. Date functions. Right. When you get to this, don't bother yourself to read the literature on this. You can just try out examples, right, so that you can see how different the extraction of those functions look like. This is PostgreSQL, right? Okay, now we can go back and solve this question. Let me go back to this. We have the Facebook database. Yes, we can solve this question. So given a table of Facebook posts, let me just make sure I go back to Facebook and connect to the database. I'm going to switch this and this. We can all do this together. Let's just go to Facebook, use Facebook. We have a couple of minutes to go. Let's just use this to solve some of these questions. This Facebook. Then next, we are looking at the post table. All of this is in DBO. Post table. So given this table right here, we are seeing the user, the post ID, the post content, and the post date. See that? Okay. Now go back to what's that question right here. So given this, for each user who posted at least twice in 2021, write a query to find the number of days between each user's first post of the year and the last post of the year. This question is not very direct, but you have to understand that we have just one column. So we want to write a query to find the number of days between each user's first post and the last post of the year 2021. And they want you to output the user as the user ID and the number of days between each first and last post. Let me ask you this question. If you're getting a single column and that's the post date, how do you get the first date a user made a post? I don't want to just go into this question directly. I want you to reason this out. So I will answer this question in little parts. Right, this is it. For each user, tell us the first post of each user. And they want us to limit this only for those that made a post in 2021. That's an easy one, right? So we just add a where clause. So I'm going to begin with this. First, I'm going to add a where clause to this, right? And only limit the post year to 2021. we need this. I cannot put post. This is what we've seen today. I cannot put post date like this equal to 2021. I think everyone should understand why we cannot do this. Because if you look at the post date column, export, it has dates all the way to the time component. It has this structure we've seen today, right? See this structure right here. It has this, and now you can interpret this based on the material we've seen today. That's the very first thing all the way at the top, and that's where I started this explanation. Everyone in class must be able to understand what this is documenting on every single row, right? On every single part of this. This right here is the year, this is the month, this is the day, and then this is the timestamp right here from hour, minute, seconds, milliseconds. See? So if you put post date equal to this, you're comparing all of these different parts into just a single part. This comparison is not balanced. See? And if you do that, you see what you get. But then there are posts that were made in 2021, you can see from the exploration. But why is this not giving any result? Because the comparison doesn't have the same basis, right? So how do we transform that the left hand and the right hand side should be of the same basis? This is what the year. So we should be transforming this into a year. And we do that through what the year function, right? I want you to understand this, right? That's the first step. So this will not just limit the Facebook posts that were made in the year 2021. This is a vital information from that question, right? And this is it. That's the first thing we do, right? So in the examples we've used, those ones were very simple and straightforward because we're dealing with two columns. There was an order date, there was a ship date, and we're looking at duration. This is a funny question because there's just one column, right? But then it's easy to know the first post that was made by each user, right? So that's the condition on that's the first part. I'm going to doing this in small parts. In this part, I just want to know the first post of each user. First post, first Facebook post of each user. I need somebody to help me with this. What will you do? So just keep it simple. Show me a user. That's what through user ID. And then can you tell me the logic we're going to use to get their first post? Before I get to this, right, maybe I show you the full picture right here. And then I throw in an order by so that we're going to see the results sorted by user ID. And then we can easily zoom into a particular user. And for example, I zoom into this user and this is the same. Now, this user had just one post in that year 2021. This user had two posts. He made two Facebook posts, two, actually three. See, the same user. See that? So of these three posts, which one of them was the very first post? That is what I'm investigating right here. Find first post of each user. So for this individual, you have to go in and look which of this one came first. This one came in January 28th. This one came towards the end of the year. This one came almost midway. So this is the first post for this individual. Given three values like that, how can you return the highest? The first, you have to understand that this is the mean function on the date. And I talked about this, that you can use the mean function on dates. And if you use mean on dates, you're returning the first date. And that's exactly what we are investigating right here. Show me each user and tell me the first post they made, the date of the first post. It's a job for the mean function. The mean of what? Mean post date. So now if I run this, it's showing us each user. Of course, we get an error because this is an aggregate function. This is non-aggregated. I have to put this in a group by. In fact, let me just transform this into group by. We no longer need the other by. The other by was just to show us the structure and that stuff. This is it. See, and that's that person I was zooming in. This one. Yes, that person who suppose came in on the first. Right. That's the use of the min function in this case. I'm showing you each user and their very first post. First post of each user. And then I'll do another second set to show you what the last post of each user. And then better still, I can just combine them. In order not first post of each user, last post of each user is simply going to transform this into max. I don't want to separate them. So now you understand the direction I'm heading to. I can now combine these two into one. To show me first and last post of each user. First and last post of each user. First and last post of each user. So this right here is what? The first post. See, I've completely ignored the question. I want to build my own, something that I can use, but it's in line with the question. And you see this a lot when it comes to problem solving. Reason out the question, and then this is Facebook stuff. We can easily understand what's going on right here. Right? If I had your data on Facebook, I can go to your history and then investigate the very first time you made a post on LinkedIn, on Facebook. And this will be through the min function. You have several posts you made in different, and the good things are the time components right there. We're tracking that as well. This is what you do. This is the first post this individual made on Facebook. For the last post, you simply convert that into what? A max function. Right. So for each individual, I'm tracking two important things. The date their first post was made, and this is the date the last post was made. If you never knew, the max function and the min functions can be used like this. This is an example. Right. So this is it. This is now showing me the first and the last post of each user right there. See that? Now, if you go back to the question now makes sense. We now want to see from the date this post was made to the date this post was made, what is the duration? Frequent Facebook users, that duration should be very small, right? But then some people post one and they make 3-4 months and they do another post. See? Right. So let me go back to the question so you can now understand. Write a query to find the number of days between each user's first post. This is the first post of the year and the last post of the year in 2021. Are we in 2021? Yes, this is the filter right there. So it is simply the difference between this and this. Remember, the original table gives us one column called what? Post date, just one column. We've now used that one column to extract, to make two columns out of it. See? So it is always good to study equation and then go back to the table and see how the data was captured. It's because of the structure of this table that we've now decided to output this into three separate columns. But originally, it's just one column. Now you all agree that this is the date the first post came in through the min function, and this is the date the last post came in through the max function. And so just like that, we've been able to take this single column and output it into two columns. And then based on these two columns, we can now calculate the duration. And that's exactly what this question is testing. Right? The number of days between each user's first post of the year and the last post of the year for 2021. And this is the column they want you to see. Output the user, which is in this case is going to be user ID, and the number of days. That's the outcome of the date function. Right. So the last thing we're simply going to do right now is, hey, create another line and then do date diff. Why date function? Because we're looking at the duration between two dates, the number of days between two events. Right. See, and now I'm going to open this. This is what number of days. Let me go back to that question and confirm. number of days. So I'm going to tell the system here, this calculation will be driven by day. Now, what is the start when the first post was made? This is the calculation right here. Please, you will make it an error if you just go and take post date. No, it's just one column. It is containing everything. But then this will now be the calculation for the start date. The main function on a date returns a date. So this is the start date. This question is a little bit twisted, but if you stay on track, you'll be able to understand what I'm doing right here. So this is the start date. And then what is the end date? The date the last post was made. This is it. So basically, what is this logic? Put everything together. This is looking at the number of days between when the first post of a user was made and the last post of that user. Remember, we're using group by, so this is showing per user. You see that? And we're looking at this only for 2021. And if I execute this, see what we get. So this user right here, their very first post came in on this date. And it's the same thing you see right here. So number of days is just 0. It's the same date the first post was made, same day the last post was made, and that's it. 0. Number of days between those two events, 0. See? Let's go for this person. Their first post came in on January 28th of 2021. Then their last post came all the way towards the end of the year, December 1st. So that's like 307 days. This person right here, the first post was made March 24th, and same post, last post, same March 24th of the same year. You see? Right. And this is exactly what they wanted. So this is not a kind of direct question. You see, I had to go through those steps. It all boils down, do you understand the question? It first of all starts by you understanding the table and understanding that we have one column. It's not like the ship did and the other did, two different columns. And right. So we needed to do a small investigation. See, for each user, let's get their first post, get their last post, and then now we can calculate the difference between those two dates when the first post was made and the last post was made. Right. This is very important. That's why I see I'm solving this thing step by step. Right. And then finally, they told us to output the user and the number of days between that. So you have to go and work out on the return. That's the select clause. I'm returning user ID first name, so I'm returning too much information. They just want this and this. They don't want to see this logic you did in between. That's for you, right? And that's exactly, let me just call this the number of days. Let's call this number of days. Let's call this column right here, number of days. Number of days, and I'm just going to connect them, underscore, connect. This is a number of days. See? So that's the column we want. So this is your build up, right? And then now this is the number of days. In fact, I think I want to do this. I want to spread it out if I join everything together. So first steps, I want to remove this, and on the exploration of that table, right, that's the first thing we did. Second, we noticed that the focus of this analysis was only for 2021. We plug in that condition and get 2021. Right. Second, the third step, we're interested to see the first and the last post of each user. So I'm going to remove this part. This is just too much. Remove that part so that you follow it step by step. All right. This is the first and last post of each user. See? And then now we can now do the number of days. Let me go back to that request. Find the number of days between each user's first and last post. Right, this part right here. This is it right here. So the requirement here has changed. Right. So sometimes you have to solve equations step by step the way you understand it. It helps. Don't just look at the question and just dive into it. Exploration is very important. And from this exploration, you get to understand that we have posted just one column, right? When did the user make their first post? We don't know, but we can find it from this column. When did the user make their last post? We don't know, but we can investigate it from this column. And that's the idea right here. Use the min function to find that, max function to find that. Yes, right. See, step by step. And then now, once we have those two investigations done, we can now find the number of days between each user's first post of the year and the last post of the year. And this is it. This is that calculation right here. First post of the year is this. Last post of the year is this. Number of days as a dative function. And this is what you get. Right. And then now to round up this and arrive at the final solution, this will now focus on the output. They want you to output the user and the number of days between that. Right. And that's the last thing we're going to do right here. It's just, respect the columns that were requested for this question. Nothing more, nothing less. I'm giving out too much information on this side. I have a total of 1, 2, 3, 4. I don't need all of that. I just need the columns that were requested. User ID. Yes, this one is going to be preserved. This and this was just to help me investigate that information. I'm going to dismiss them. And then finally, we can now get the number of days. And this is the logic for the number of days. That's a dative function. Now, these are the two columns that were requested. Right. You see what it takes to hit your final solution. See, if this, so you have to follow the steps. So this is your step 1, which is data exploration. Right. You're just exploring the table. Very, very important. Always have these steps in mind. Table exploration. Right. It's from this exploration we discovered that we have just a single column for the date. That's the post date. Right there. And we needed to the second one, adding the condition on the year. Step 2, condition on year. Because the question wanted us to look at only the posts that came in 2021. That's it. This is our step 2. Right. What did we do in step? This is step 2. What did we do in step 3? We investigate first and last post of each user. That's step 3. Investigate first and last post of each user. And that's exactly what we did here in step 3. We're investigating using the min and max function, you see. Right. And we're still keeping that condition. Right. That's it. Step 3. Investigate first and last post of each user. That's it. And in step 4, basically, we apply that. Step 4, find the number of days between this and this. So we are using the dative function right here. The dative function to investigate that difference of the two information we've retrieved above, right? And this, I'm still showing the full examples. It's the full solution right here, right? And then step 5, that's the final outcome. Output the result. This is final outcome. Now respecting this is step 4, final outcome. Or I can just put the final output. And that's the final output, putting everything together. That's it. It's the final result. In fact, I'm going to share this with everyone. and that helps. The question could look very funny, but then if you take your time and go step by step, you can do great things, right? So this is it right here, Facebook one. Where can we fit this all the way towards the bottom? Yes, I'm going to put it somewhere right here. Yes, and this is really, really important. And I think to make this interesting, you can just go back to that link and copy the, the page. This is the address to that page. Let's put it right here. So this question is coming from this. All right. Okay, any question before we go? So this was a focus for today. I just wanted to get into those date functions. There's one we've left out, which is this isDate. It's just an investigation. All right. This function is just an investigation. Let me show you how it's done. First, you must have a column that is not a date, and then you want to investigate if it's having a date, if it's actually a date. For example, today's date is 2024 02 17. That's actually a date. So an investigation will give you 1 if it's a date, and then 0 if it's not a date. This is investigation. 1 means true, 0 means false. So that's a date right there. Now, if I just take a quick look at my calendar, the month of February of 2024 has 29 days. Okay, see the challenge I want to do on this function. I will change this into what? 30. If you check your calendar, there's no 30 day on the month of February. So if I run this, this is not a valid date. So I expect that this investigation should give me 0. See that that's the isDate is an investigation. Is this expression a date? It's a question mark interrogation. If it is yes, you get 1. If it's no, you get a 0. Right. Now normally we have 12 months on the calendar. Right. If I come right here and put this 13 and I put this maybe 05, maybe in some countries we write the date by putting the year first. We put the day, the month, and then this. So this thing follows that layout. I think we talked about this layout. You have to always go back and consult this layout and understand it. Right. For those of you in Africa, I know we do things differently. We always do the day, the month, and the year. In America, they do it different. They have to put the month first, month, they put the day, and then they put the year. So it's kind of twisted the way they do it in the US. But then if you look at the way SQL Server is doing it, is relying on the international, the standard way of dates, so that everyone can see this and no confusion. The highest hierarchy is the year, followed by the month, followed by the day. Yeah, this is very important. So this is the international standard, right? So dates are kind of tricky. If you have a business that runs across different countries, it could really, really be a problem on the reporting dates. You must make sure that you standardize it. Right, this is the international way. In America, today's date, you have to put the month, the day, and then followed by the year. This is how you're going to report today's date in the US 2024. Right. Yeah, but then in Europe and other parts of Africa, They kind of keep it easy. From the lowest hierarchy, you have to start by telling us the day. That's the lowest hierarchy. And then you go to the month, second hierarchy, and then the highest now is this 2024. Right, if you write a date like this in the US, this will be interpreted. This is different. See that? This is what they want to see. But then, of course, without any confusion, this is the international format. Right? This hierarchy will be respected. This is the month, the year, the month, and the day. See that? So if you have a business that cuts across multiple countries with different ways of reporting dates, it could be problematic. You have to make sure you standardize the date format. If not, you have serious confusion. Are we okay? Right. So the is date is just to test and see if something is a date. Right. I was talking about this one. This is following this format. This is the year, this is the month, and this is the day. There is no 13 month on the calendar, so this is not a date. This give for 0. And then we also talked about this one. This is the month of February. February of 2024 on the calendar. There's no 30 day. The last day is the 29th. So this is not a date because of this violation right here. Execute to get a 0. This is a valid date. Today's date is February 17, 2024. This is valid. You get a 1. So each date is just an investigation. Right. Okay, we're gonna stop here. Tomorrow we're gonna continue with other functions. Right, but hopefully you'll be able to see this, and I think during the lab session I'll bring you back to this and we're gonna practice more examples. But unfortunately, the way we are coding the date functions is completely different from what you see on this working document. But of course, we can rely on the examples. We have a database, we can challenge ourselves on those. Right. So I want you guys to go back and review this example, step 1 all the way to the last step, which projects the final solution. Right. Okay, let's stop right here. See you tomorrow.
Yeah. Goodbye. See you tomorrow.
Okay, see you tomorrow. Okay.